Imagine a world where everything you thought you knew about human history is turned upside down, not because we dug up something brand new, but because we finally looked closer at what's been right in front of us all along. Hidden away in museum storage rooms, tucked inside forgotten archives, and even sitting openly in gallery displays, there are objects that defy explanation, artifacts so advanced, so curiously out of place, that they whisper secrets of a past far more sophisticated than our textbooks dare to admit. For generations, these items were dismissed as religious trinkets, burial ornaments, or simply mistakes. But what if they weren't mistakes at all? What if they were evidence? We've been taught that technology evolved in a neat, orderly line, from stone tools to silicon chips, with each era building clearly on the one before. But that story is starting to crack. All around the world, artifacts are surfacing, or more accurately, being re-examined, that suggest ancient civilizations may have grasped concepts we thought were modern inventions. Think about it, a 2,000-year-old battery, a clockwork computer from antiquity, navigation tools that guided sailors across trackless oceans without a compass in sight. These aren't sci-fi fantasies, they're real objects waiting patiently for us to see them not as anomalies, but as clues. In this video, we're going to explore 21 of these breathtaking artifacts, each one misclassified, misunderstood, or outright ignored for centuries. Together, they sketch the outlines of a different kind of history, one where innovation isn't always linear, where knowledge isn't always preserved, and where the past holds wonders we're only beginning to recognize. This isn't just about rewriting timelines, it's about rediscovering the ingenuity, the ambition, and the sheer brilliance of those who came long before us. So come with me, let's pull back the curtain on the mysteries hiding in plain sight and reimagine history not as a straight path, but as a rich, complex tapestry of human creativity, one that still has so much left to reveal. But to truly grasp why these objects were misunderstood for so long, we have to step back and examine the very framework of discovery itself. For generations, the brilliant minds tasked with unearthing our past were, like all of us, products of their time. They carried with them a set of deeply ingrained beliefs about cultural evolution, a rigid, almost linear progression from primitive to advanced. When an artifact was unearthed that shattered this comfortable timeline, the cognitive dissonance was simply too great. It was far easier to assign a mystical or decorative purpose to a finely crafted bronze gear than to entertain the notion that ancient people might have possessed a form of engineering prowess that rivaled their own. This wasn't always a matter of arrogance, often it was a limitation of context. An archaeologist from the 19th century, for instance, living in a world of steam and early electricity, had no personal experience with analog computers. So when confronted with a complex arrangement of gears, like those in the Antikythera Mechanism, the most logical conclusion to their Victorian mind was that it must be an astrolabe or an ornate religious calendar. Their toolbox for understanding was, through no fault of their own, incomplete. They categorized the unfamiliar based on the familiar, a practice that inevitably led to a vast museum of mislabeled marvels. A clay pot with an iron rod and a copper cylinder couldn't possibly be a power source. It had to be a scroll holder. A crystal found in a Viking grave wasn't a sophisticated navigational aid. It was just a pretty rock for a cherished ornament. This tendency created a powerful feedback loop. Once an object was officially classified in a textbook or a museum display case, that label gained the weight of authority. It became the accepted truth, repeated by generations of scholars who saw no reason to question the conclusions of their esteemed predecessors. The artifact itself became trapped by its own provenance, its true story silenced by a placard that read, "Ritual object of unknown purpose." This systemic inertia is a formidable force in academia, making it incredibly difficult to challenge long-held interpretations without overwhelming new evidence. The true function of these objects remained hidden not in the sand, but in the assumptions of the people who brushed the sand away. It took a revolution in technology and methodology to begin untangling this centuries-old knot. The advent of non-invasive tools like CT scanners and spectroscopy allowed researchers to peer inside objects without damaging them, to analyze residues invisible to the naked eye, and to understand material compositions at an atomic level. Suddenly, we could see the wear patterns on a gear that indicated decades of use, or detect traces of ancient vinegar inside a sealed jar. This empirical data provided the hard evidence needed to challenge soft assumptions. Furthermore, the rise of interdisciplinary studies broke down the silos between historians, engineers, chemists, and astronomers. An engineer could look at the aerodynamics of a wooden bird and see a prototype for flight, while a chemist could explain the deliberate alloy that made an iron pillar rust-proof. This collaborative approach finally gave these artifacts the audience they deserved, one capable of understanding their language. We are now in the midst of a great re-evaluation, slowly peeling off the outdated labels and listening, at last, to what these incredible objects have been trying to tell us all along. So how do we correct these centuries of misunderstanding? The answer lies in a revolutionary new toolkit that blends the meticulous digging of traditional archaeology with the breathtaking precision of 21st century science. It's no longer enough to simply brush the dirt off an object and make an educated guess based on its appearance. Today's researchers approach these puzzles like forensic detectives at a crime scene, gathering every possible clue to reconstruct the truth. This process often starts with advanced imaging techniques. Computed tomography, or CT scanning, allows us to peer inside sealed artifacts without ever cracking them open, mapping intricate internal structures and hidden components that were completely invisible to previous generations. We can see the precise interlocking of gears within a corroded lump of bronze, or trace the fine residue of a forgotten substance inside a sealed ceramic vessel. Material analysis provides another crucial layer of evidence. Using methods like X-ray fluorescence and spectroscopy, scientists can determine the exact elemental composition of an object down to parts per million. This tells us not just what something is made of, but often how it was made. The specific alloys in a metal tool can reveal the smelting temperatures and techniques used, while the residue on a stone blade can tell us if it was used to cut meat, plants, or even other stone. This data moves us from speculation into the realm of hard, empirical fact. But technology alone isn't the whole story. Experimental archaeology brings these ancient objects to life in a wonderfully tangible way. Researchers create painstakingly accurate replicas using period-appropriate tools and materials, then test them to see how they actually function. Can a clay jar generate an electrical current? Does a wooden model with a peculiar shape actually fly? By physically trying to use these objects as their original creators might have, we move beyond abstract theory and into practical understanding. This entire investigative process is guided by a crucial philosophical principle known as Occam's razor, the idea that the simplest explanation that accounts for all the available evidence is usually the correct one. For a long time, the simplest explanation for a strange object was to label it ceremonial because that required no further investigation. But now, with our expanded toolkit, the simplest explanation is often a practical one. When a crystal found in a Viking grave can demonstrably pinpoint the sun's location on a cloudy day, the simplest explanation is that it was a navigational tool, not a mere ornament. This doesn't mean we dismiss the spiritual or cultural significance of artifacts. Rather, we recognize that the sacred and the practical were often deeply intertwined in ancient societies. A tool used for precise astronomical measurement could also hold profound ritual importance for tracking the seasons. This multidisciplinary, evidence-based approach is slowly and methodically dismantling old assumptions, allowing us to finally hear the faint whispers of ingenuity from the past and piece together a technological timeline that is far more surprising and far more human than we ever imagined. Now let's turn our attention to the first and perhaps most astonishing artifact on our list, a humble clay jar that quietly appends one of the most fundamental narratives in the history of science. Discovered in 1936 in a 2,000-year-old village near Baghdad, this unassuming pot doesn't look like much at first glance. It's a simple, egg-shaped vessel of yellowish clay, roughly the size of a man's fist. But its contents are anything but ordinary. Inside, archaeologists found a carefully rolled sheet of copper, forming a cylinder, and nestled within it an iron rod. The two metals were kept separate by a stopper made of asphalt, a naturally occurring bitumen, which also sealed the top of the jar perfectly. To the excavators, it was a curious find, perhaps a unique container for holding sacred scrolls. It was catalogued, stored away, and for a time, its true potential remained completely dormant, much like the energy it would later be found to hold. It wasn't until several years later that a key insight began to shift this interpretation. A German archaeologist named Wilhelm Koenig, who was director of the National Museum of Iraq, took a much closer look at the jar and its peculiar construction. He was struck by the deliberate way the two different metals were isolated from each other by the asphalt plug. This wasn't a random arrangement, it was a design. Koenig had a revolutionary thought. What if this wasn't a storage jar at all? What if it was meant to be filled with a liquid? He theorized that if an acidic solution, something as common as vinegar or fermented grape juice, was poured into the vessel, it would surround both the iron rod and the copper cylinder. The acidic liquid would act as an electrolyte, creating a chemical reaction between the two dissimilar metals. In essence, he was looking at the components of a simple galvanic cell, a basic battery. To test this bold hypothesis, modern researchers built precise replicas of the jar using materials that would have been available in the Parthian era. When they filled these replicas with an electrolyte like vinegar, the results were nothing short of electrifying. The devices generated a measurable voltage, a small but consistent electrical current of around 1 to 2 volts. It wasn't enough to power a city, of course, but it was a genuine and controllable flow of electricity. This wasn't a theoretical possibility, it was a practical, demonstrable fact. The so-called scroll jar was, without a doubt, capable of producing electricity. This single finding forces us to completely reimagine the technological landscape of ancient Mesopotamia. While Alessandro Volta is rightly credited with inventing the first electrochemical battery in the year 1800, this artifact suggests the fundamental principle was not only understood but actively employed some 2,000 years earlier. This immediately raises the compelling question: what would an ancient civilization do with a small electrical current? Without light bulbs or motors, the applications would have been different but no less ingenious. The most plausible theory is electroplating, the process of using electricity to bond a thin layer of a precious metal, like gold or silver, onto the surface of a less valuable object, like a copper statue or a piece of jewelry. This technique was known to be used in the region, but historians had always assumed it was achieved through a chemical method called cementation. The battery provides a far more elegant and efficient explanation. A skilled artisan could have connected several of these jars together to create a higher voltage, dipped wires attached to the metals into a gold salt solution, and beautifully gilded small objects. The effect would have seemed like magic, transferring the brilliant sheen of gold onto a common item with an invisible force. Another fascinating possibility lies in the realm of medicine. Ancient texts from various cultures, including those near the region, describe the use of electric fish to numb pain and treat ailments. The Greeks wrote of using the shock from a torpedo ray to alleviate headaches and gout. If the concept of using electricity for therapy was known, then having a device that could generate a similar, controllable tingling sensation would have been a powerful tool for a healer. A mild shock from such a battery could have been applied to relieve muscle pain, or even used in mystical rituals to create a sense of divine energy flowing through a patient. The psychological and physiological effects, whether fully understood or not, would have been very real. This single, simple jar opens a window onto a world where the boundaries between science, art, and magic were beautifully blurred, revealing a sophistication we are only just beginning to appreciate. If the Baghdad Battery redefined our understanding of ancient energy, then the next artifact on our list shatters the entire timeline of computing a ND Chinese letter, Chinese letter, Chinese letter, Chinese letter. Picture this, it is the year 1901. A team of sponge divers, seeking refuge from a storm off the coast of the tiny Greek island of Antikythera, discovers the wreck of an ancient Roman cargo ship. Among the stunning statues and treasures they bring up is a lump of heavily corroded bronze, encrusted with 2 millennia of sea life. To the untrained eye, it was little more than a piece of junk, a curiosity that was catalogued along with the other finds and largely forgotten for nearly half a century. It was initially labeled as a piece of a navigational astrolabe, or perhaps an ornate astronomical clock from a much later period that had somehow fallen into the wreck. This classification was a product of its time. The technology it seemingly represented was so advanced that historians simply could not conceive of it belonging to the ancient world. It was easier to assume a mistake in provenance than to accept that such a device could be 2,000 years old. The truth began to emerge in the 1950s when a science historian named Derek J. de Sola Price took an interest in the peculiar object. As he carefully examined the layers of calcification and corrosion, he noticed something astonishing: intricate gear trains embedded within the rock-hard mass. This was no simple clock or navigational aid. Using the emerging technology of gamma-ray imaging, he and later teams of researchers were able to peer inside the corroded shell without destroying it. What they revealed was nothing short of breathtaking. The Antikythera Mechanism, as it came to be known, was an incredibly complex assembly of at least 30 interlocking bronze gears, precisely cut and mounted within a wooden frame. It featured dials on both its front and back, marked with ancient Greek inscriptions and a series of intricate pointers. This was not a tool for simple measurement. It was a device for calculation, a machine designed to model the cosmos itself. So what exactly did this ancient computer do? Its primary function was to predict celestial events with remarkable accuracy. By turning a hand crank on its side, the operator would engage the sophisticated gear trains, causing the various pointers to move across the dials. On the front, one dial likely showed the position of the sun and moon against the backdrop of the Egyptian zodiac, while a beautiful rotating ball, half white and half black, displayed the phases of the moon. But the real magic was on the back. One dial was a 19-year Metonic calendar, used to track lunar cycles and predict eclipses. Another was a 76-year Callippic cycle, refining the calendar further. Perhaps most astonishing of all was a small dial that predicted the timing of the ancient Olympic Games and other major Panhellenic festivals, a 4-year cycle that was of immense cultural and social importance to the Greek world. This was a machine that seamlessly wove together the celestial and the terrestrial, the scientific and the social, into a single, elegant, mechanical symphony. The engineering sophistication required to create such a device is almost beyond belief for its time. The gears were not simple spur gears. They included differential gearing, a complex arrangement previously thought to have been invented in the 16th century for automobile axles. This system allowed the mechanism to account for the irregular orbit of the moon, showing its changing velocity as it traveled across the sky. The teeth of the gears were cut with such precision that the entire mechanism could accurately model astronomical cycles that span decades. The knowledge of astronomy encoded within its bronze plates is equally profound. It incorporates Babylonian theories of planetary motion and Greek geometrical models, representing a fusion of scientific knowledge from across the Hellenistic world. This was not the work of a lone genius tinkering in a shed. It was almost certainly the product of a scholarly tradition, a school of thought that understood gear ratios, celestial mechanics, and complex manufacturing to a degree that historians never knew existed in antiquity. The existence of the Antikythera Mechanism forces a complete re-evaluation of the technological landscape of the ancient world. We can no longer view the Greeks solely as brilliant philosophers and theorists who lacked practical application. Here is irrefutable evidence that they could translate their abstract mathematical theories into tangible, working machines of stunning complexity. It suggests a level of mechanical engineering that was utterly lost for over 1,000 years. One can only wonder what other devices were created, mentioned perhaps in lost texts or hinted at in fragments of poetry. Did Archimedes, who was said to have built a mechanical planetarium, create something similar? Was this mechanism a one-of-a-kind luxury item for a wealthy patron, or was it an example of a more widespread, but now almost entirely vanished technology? Its discovery on a trading ship indicates it was an object of value, being transported from one corner of the empire to another. Its very presence forces us to replace our image of the ancient past, inserting into the quiet halls of philosophers and the libraries of Alexandria the soft, persistent ticking of gears, counting down the cycles of the heavens with a precision the world would not see again for centuries. While the Antikythera Mechanism represents a genuine technological marvel that was simply misunderstood, our next artifact serves as a powerful cautionary tale about the seductive allure of a mystery and the critical importance of rigorous scientific process. In February of 1961, 3 men were prospecting for geodes near the town of Olancha, California, near the Coso Mountains. They were cracking open the round, rocky nodules, hoping to find beautiful crystal-lined cavities inside. When one of them split a particularly promising specimen, they were met with a sight that defied all logic. Instead of glittering crystals, they found what appeared to be a modern spark plug, perfectly encased within the rock. The object had a ceramic insulator surrounding a magnetic metal core, all contained within a hexagonal metallic shell. It looked for all the world like a component from an early 20th century engine. The baffling part was the geology. The hard, dense layer of hardened clay and pebbles surrounding it, known as a concretion, appeared to be incredibly ancient. Initial analysis only deepened the enigma. A geologist who examined the find estimated that the concretion process would have taken a significant amount of time, perhaps 500,000 years. This single assessment, which was far from conclusive, was enough to ignite a firestorm of speculation. If the spark plug was 500,000 years old, it meant it predated not only modern humanity, but even our early hominid ancestors. The implications were staggering. The artifact, quickly dubbed the Coso Artifact, became a favorite piece of evidence for those who believed in ancient advanced civilizations like Atlantis or Mu, societies that supposedly possessed technology rivaling our own before vanishing without a trace. For proponents of the ancient astronaut theory, it was a smoking gun, definitive proof that extraterrestrial visitors had left their tools behind on Earth in the distant past. The story was irresistibly compelling, a perfect fusion of science fiction and pseudo-archaeology that captured the public imagination and seemed to completely upend the established timeline of human progress. The mystery persisted for decades, fueled by the artifact's disappearance into a private collection, which made further independent study impossible. It became a legend, an anecdote repeated in books and documentaries about out-of-place artifacts, or UParts, presented as definitive proof that mainstream science was hiding the truth about our past. The narrative was simple and powerful. A modern object found in ancient rock, therefore, our history must be wrong. This line of thinking, however, makes a critical error by prioritizing an exciting conclusion over a meticulous examination of the evidence. The initial geological assessment was just that, an initial guess, not a peer-reviewed definitive dating. Concretions can form with surprising speed under the right chemical conditions, especially around a man-made object that itself influences the mineralization process. The spark plug was never subjected to the kind of thorough, multi-method analysis that would become standard practice, and the most extraordinary claim in archaeology was resting on the shakiest of foundations. The truth finally emerged when a dedicated researcher named Pierre Stromberg and a physicist named Paul Heinrich managed to track down photographs of the artifact and compare it to known examples of early spark plugs. Their investigation was a masterclass in applied skepticism. They identified the object not as a mysterious relic, but as a champion brand spark plug from the 1920s, a fairly common model for its time. The ceramic insulator was actually porcelain, and the mysterious metal shell was a simple rust-resistant alloy. The final piece of the puzzle was the context of its discovery. The area around Olancha was not a pristine ancient landscape. It had a history of mining, logging, and transportation dating back to the late 1800s. Early automobiles and machinery were common, and it was entirely plausible that a spark plug from a broken-down truck or a piece of mining equipment had been discarded on the ground. In the unique mineral-rich environment, particularly one with a source of lime from nearby limestone deposits, a concretion could form around the object in a matter of decades, not millennia, encasing it in a shell that merely looked ancient to the untrained eye. The real significance of the Coso Artifact, therefore, has nothing to do with ancient astronauts or lost civilizations. Its true lesson is a profound one about the scientific method and the human psyche. It demonstrates how a desire for mystery, a longing for a past that is more exciting and enigmatic than the one we know, can lead even well-intentioned people to abandon critical thinking. It shows the danger of latching onto a single piece of preliminary data and building an entire world-altering theory upon it while ignoring simpler, more plausible explanations. This case underscores why the archaeological process must be slow, careful, and relentlessly self-correcting. It requires not just finding an object, but understanding its material composition, its archaeological context, and its history. The Coso Artifact reminds us that extraordinary claims require not just extraordinary evidence, but reproducible, verifiable, and overwhelming evidence. It's a story that continues to resonate because it's not really about a spark plug. It's about our own capacity for wonder and our responsibility to temper that wonder with reason, ensuring that the real marvels of the past, like the Antikythera Mechanism, are given the credibility they deserve, free from the distracting noise of unsolved mysteries that were, in the end, just waiting for the right tools to solve them. Now, let's set sail from the sun-drenched Mediterranean to the fog-shrouded, violent seas of the North Atlantic, where our next artifact solves a mystery that has puzzled historians for centuries. The Vikings, those legendary explorers and raiders, accomplished a feat of navigation that seems almost supernatural. They sailed their iconic longships from the fjords of Scandinavia across thousands of miles of open, treacherous ocean, reaching Iceland, Greenland, and even the coast of North America, all without the magnetic compass, an instrument that wouldn't reach Europe for hundreds of years. For generations, scholars pored over the Norse sagas, the epic poems that chronicled these voyages, searching for clues. The text spoke of a solarstein, a sunstone, but its description was vague, lost in the mists of poetic language. It was easy to dismiss it as a metaphor, a mythical object like a lucky charm or a symbol of divine favor from the gods, another piece of colorful folklore from a culture rich with stories. This interpretation held sway for a very long time, comfortably filed away under mythology. But then, a pivotal discovery in 2002 began to change everything. A team of marine archaeologists investigating the wreck of an English warship that sank in 1592 made an astonishing find. Among the navigational tools on the captain's table was a small, transparent block of crystal, identified as a piece of Iceland spar, a remarkably pure form of calcite. This was not a random piece of treasure. Its location suggested it was a vital part of the ship's equipment, used alongside the more traditional dividers and compasses. This physical evidence, a sunstone found in a real nautical context, provided the crucial link between the Viking sagas and a tangible, functional object. It proved that the concept wasn't just a myth. It was a technology that had persisted in maritime use for centuries after the Viking Age, a secret weapon for sailors battling overcast skies. So how does a simple piece of crystal replace the sun? The answer lies in a beautiful and subtle property of light known as polarization. Sunlight, as it travels through our atmosphere, becomes polarized, meaning its light waves vibrate in a specific direction. This is invisible to the human eye, but not to a crystal like Iceland spar. This remarkable mineral has a property called birefringence. It splits a single beam of light into two separate beams. A skilled navigator could hold the stone up to the sky, even on a completely overcast day when the sun was just a diffuse, gray brightness behind the clouds, and slowly rotate it. By looking through the crystal and watching for the point where the two beams of light inside it are of equal intensity, they could pinpoint the exact location of the hidden sun. It's a process that turns an invisible physical phenomenon into a visible, actionable piece of data, a celestial compass hidden within the fabric of the sky itself. Researchers didn't just take this theory on faith, they put it to the test in the most rigorous way possible. In 2011, a team of optical physicists led by Guy Ropars built replicas of the Sunstone and took them to sea. Their experiments were definitive, even when the sun was up to 7 degrees below the horizon during twilight or under thick cloud cover. A trained user could determine the sun's position with an accuracy of within 1 degree. To put that in perspective, that's a level of precision that would have been more than sufficient to guide a longship from Bergen in Norway to the southern coast of Greenland, a voyage of over 1,500 miles. Another fascinating experiment used a computer model to simulate 3,600 Viking voyages between Norway and Greenland. The results showed that using a sunstone to take a reading even just once every 4 hours would have resulted in a successful landing between 92 and 100% of the time. Without it, the success rate plummeted. The data was incontrovertible. This was not a quirky folktale. It was a sophisticated and highly effective navigational system. This reclassification is monumental. It transforms the Viking Sunstone from a curious mention in a poem into a foundational piece of technology that enabled one of history's greatest eras of exploration. It reveals that the Vikings weren't just brutal warriors or lucky sailors. They were keen observers of the natural world who possessed a profound, almost intuitive understanding of optics and astronomy. They learned to read the secrets written in the light itself. This discovery also beautifully illustrates a crucial principle of historical investigation: the importance of taking oral traditions seriously. For too long, the stories of non-literate or semi-literate cultures were seen as less reliable than written texts, often dismissed as mere legend. The saga of the Sunstone teaches us that these stories are often encoded manuals, preserving critical knowledge across generations. They are not just entertainment, they are the vessels of forgotten science, waiting for the right key to unlock their practical truths. The Vikings didn't need to write down the instructions for using the Sunstone. Every navigator learned it from his father, who learned it from his. The technique passed down through the generations along with the stories of great voyages, until the stories themselves became the only thing that remained, a ghost of a technology waiting for us to listen. From the stormy northern seas, we now travel to the dry, still air of the Egyptian desert, where an object of delicate beauty waits to challenge our assumptions about the origins of flight. Discovered in 1898 during the excavation of a tomb in Sakara, this artifact was one of many wooden figures placed as grave goods to accompany the deceased into the afterlife. To its discoverers, it was immediately recognizable: a bird, crafted from sycamore wood and dating to around 200 years before the Common Era. It was a beautifully stylized falcon or hawk, complete with a distinctive beak and eyes, and it was catalogued without much fanfare as yet another ritual object, a symbolic representation of a deity or perhaps a beloved pet for the journey beyond. For nearly 70 years, it sat in the Cairo Museum, labeled and displayed as a fine example of Ptolemaic-era funerary art, its true potential for flight completely grounded by the weight of conventional interpretation. The turning point came in 1969 when Dr. Khalil Messiha, an Egyptologist and model aircraft enthusiast, was examining the museum's collection. His trained eye saw something that everyone else had missed. While the object had the general shape of a bird, its features were not quite right. The wings were not rounded or soft like those of a perched bird. They were straight, sharply angled, and had a distinct cambered cross-section that was eerily familiar to him. He recognized it instantly as an airfoil, the same carefully shaped surface that gives an airplane wing its lift. Then he looked at the tail. It was not the forked or fanned tail of a bird in flight. It was a vertical, fin-like stabilizer, exactly like the rudder on the tail of a modern aircraft. This was no mere coincidence of artistic license. To Messiha, it looked like a carefully engineered design, a model of something built not to mimic nature, but to harness its principles. This radical reinterpretation sparked immediate controversy. Could the ancient Egyptians have understood the principles of aerodynamics? The mainstream archaeological community was deeply skeptical, arguing that it was likely just a child's toy or a weather vane, and that seeing an airplane in a bird was a classic case of pareidolia, the human tendency to find familiar patterns in ambiguous shapes. The only way to settle the debate was to move it from the museum display case to the workshop. Enthusiasts and engineers began building precise, scale replicas of the Saqqara Bird, carefully weighting them to match the density of the original sycamore wood. When these models were thrown by hand, the results were startling. The little wooden artifact didn't just fall to the ground, it soared. It demonstrated remarkable gliding capabilities, catching the air under its wings and flying for considerable distances with impressive stability. The vertical tail fin prevented it from spinning out of control, acting exactly as a modern aerodynamic stabilizer would. The tests proved that, whether by brilliant accident or by deliberate design, the object was functionally aerodynamic. It wasn't just a carving, it was capable of flight. This opens up a fascinating and complex series of questions about its purpose. If it was designed to fly, what was it for? The most plausible theory is that it was a sophisticated throwing toy, an ancient equivalent of a balsa wood glider. It's easy to imagine a child in Ptolemaic Egypt playing with it in a courtyard, or perhaps a craftsman using it to demonstrate a principle of physics. Another compelling idea is that it served as a ritual object, but with a very specific function. In Egyptian mythology, the ability to fly was associated with the gods and the soul's journey to the afterlife. A model that could physically achieve flight might have held profound symbolic power, a tangible representation of the soul's ascent. It could have been a ceremonial object used in a specific ritual, thrown to symbolize the flight of the spirit. This blends the practical with the spiritual in a way that was common in many ancient cultures, where an object's effectiveness in the physical world reinforced its power in the metaphysical one. The true significance of the Saqqara bird lies not in proving the existence of ancient airports, but in forcing us to expand our definition of scientific inquiry. We often imagine the path to flight beginning with Leonardo da Vinci's sketches in the 15th century, then jumping to the Wright brothers at Kitty Hawk in 1903. This artifact suggests a much longer, more sporadic, and more global curiosity about the secrets of aerodynamics. It hints at a process of empirical discovery, where ancient scientists and craftsmen observed the world around them. The way a curved surface cuts through the air, the way a vertical fin keeps an arrow straight, and experimented with those principles in tangible form. They may not have had the mathematics of Bernoulli's principle or the materials to build a full-scale engine, but they possessed a powerful combination of keen observation and practical experimentation. The Saqqara bird stands as a quiet but powerful testament to that timeless human urge to look at a bird in the sky and not just wonder, but to try and understand, to replicate, and to one day join it. Standing proudly in the courtyard of the Qutb Minar complex in Delhi is a silent sentinel that has defied one of nature's most relentless forces for over 16 centuries. The Iron Pillar of Delhi, a towering column of wrought iron stretching 7 meters towards the sky and weighing over 6 tons, has long been a celebrated landmark. For generations, historians and visitors alike marveled at its mere existence, a testament to the sheer scale and ambition of ancient Indian iron production. It was admired, quite rightly, as a monumental achievement, a symbol of power and devotion erected during the reign of the Gupta Empire around the year 400 of the Common Era. The inscription carved into its surface, praising a king named Chandra, was the primary focus, while the pillar itself was seen as the magnificent, if rust-streaked, canvas for this message. The fact that it was still standing was remarkable enough. The true miracle hiding in plain sight was its stunning state of preservation, a mystery that was casually attributed to the dry climate, or perhaps just a fortunate accident of metallurgy, a happy coincidence in a world where iron is synonymous with decay. This comfortable assumption began to crumble under the gaze of modern science. While the air in Delhi is certainly not the humid, salt-laden atmosphere that accelerates corrosion, it is far from a dry, inert environment. The city experiences a monsoon season, with periods of significant rainfall and humidity that should have begun eating away at the iron centuries ago. Other iron artifacts from the same period, even those found in much drier regions, show extensive rust and deterioration. The pillar was an obvious outlier, and its unique resistance demanded a deeper investigation. When researchers in the 19th and 20th centuries finally turned their advanced tools upon it, using techniques like X-ray diffraction and spectroscopy to analyze its microscopic structure, they discovered the secret wasn't luck or climate. It was a masterclass in materials engineering. The entire surface of the pillar is shielded by a thin, protective film, a passive layer only about 50 micrometers thick, about the width of a human hair. This layer was identified as a compound called mesowite, a complex iron oxyhydroxide phosphate that is incredibly stable and non-reactive. It acts as an invisible, impenetrable barrier, preventing oxygen and moisture from reaching the vulnerable pure iron beneath. This isn't a paint or an applied coating. It is a skin that grew from the metal itself, a direct result of its unique chemical birth. The creation of this protective shell was no accident. It was the direct and deliberate result of a sophisticated smelting process that modern industry had long abandoned. The ancient Indian metalworkers, known as Lohavadiyas, used a specific method to produce their high-quality iron, known as wootz steel, which was famed across the ancient world. For this pillar, they employed a technique that involved a unique ore blend and a high phosphorus content. While modern metallurgy views phosphorus as an impurity that makes steel brittle, these ancient masters turned this flaw into a foundational feature. Their process resulted in an iron alloy with a remarkably high phosphorus content of about 1%, compared to less than 0.05% in most modern steels. It was this high phosphorus level, combined with the specific slag inclusions from their forging process and the initial exposure to the atmosphere, that catalyzed the slow, controlled formation of the mesowite layer. Over the first few years of the pillar's life, this protective skin grew, stabilizing and hardening into the perfect shield. The skill involved is breathtaking. They weren't just making iron, they were programming it to protect itself for millennia, understanding the long-term chemical reactions on a level that would not be replicated until the 20th century with the invention of stainless steel and other corrosion-resistant alloys. This revelation completely transforms our understanding of the pillar's purpose and the society that created it. It moves the object from the category of impressive monument into the realm of advanced technological artifact. It was not merely built to be large, it was engineered to last. This suggests a profound and nuanced understanding of chemistry and long-term planning that we rarely associate with the ancient world. The inscription on the pillar speaks of a king whose glory was as boundless as the oceans. The metalworkers who executed his vision took that sentiment literally, creating a physical object whose endurance would indeed become boundless, outlasting dynasties, invasions, and the rise and fall of entire civilizations. They were not just artisans, they were material scientists conducting a 1,000-year experiment that is still running today. The pillar ceases to be a static relic and becomes a dynamic testament to a culture that valued permanence, knowledge, and the sublimation of natural forces through human ingenuity. The legacy of this ancient innovation extends far beyond a tourist attraction in Delhi. The pillar's stubborn refusal to rust has become a major area of study for modern scientists and engineers grappling with the colossal economic problem of corrosion, which costs the global economy trillions of dollars every year. They are intensely studying the formation and properties of the mesowite layer, hoping to reverse engineer the ancient process to develop new, more effective, and more environmentally friendly methods for protecting modern steel structures, from bridges and buildings to ships and pipelines. The goal is to create a self-healing protective layer similar to the one on the pillar, perhaps through smarter alloy design or controlled surface treatments. The irony is profound and beautiful. In our relentless pursuit of the next new material, from graphene to carbon nanotubes, one of the most durable and elegant solutions to a modern problem has been standing quietly in an Indian courtyard for 1,600 years, waiting for us to develop the tools to understand the wisdom it was forged with. It is a humbling reminder that advanced technology is not always about what comes next. Sometimes it's about recognizing the brilliance of what came before. If the iron pillar of Delhi represents a technology of serene and lasting peace, our next artifact embodies its terrifying opposite, a weapon of such destructive fury that its very existence was long thought to be a fireside tale, an exaggerated legend from a brutal age. For centuries, accounts of Greek fire were filed away in the dusty cabinets of history as myth, the ancient equivalent of a tall tale. Byzantine chroniclers wrote of a liquid flame that could not be extinguished by water, that clung to ships and men like demonic glue, and that was ejected from bronze tubes with a thunderous roar and a great cloud of smoke. It sounded less like a historical weapon and more like a description from a fantastical epic, a dramatic embellishment to make naval victories sound more impressive. Scholars, unable to reconcile these descriptions with any known ancient technology, comfortably dismissed it as propaganda or the misunderstanding of primitive incendiary arrows and pots of burning pitch. The secret, it seemed, was not just lost to time, but perhaps had never existed at all. This comfortable skepticism began to evaporate in the face of meticulous historical and chemical detective work. The key was to stop reading the accounts as fantasy and start reading them as technical manuals. The descriptions were simply too consistent across too many different sources over hundreds of years to be pure invention. This was a real weapon, and its tactical impact was undeniable. It was the ultimate naval deterrent for the Byzantine Empire, the superweapon that allowed their often outnumbered fleet to dominate the Mediterranean for centuries, most famously saving Constantinople from two separate Arab sieges. The reports were clear. This was not a simple fire. Water seemed to feed it, sand could sometimes smother it, but the only truly reliable method was to douse it in vinegar or old urine, a clue that pointed strongly to a chemical reaction rather than a simple fuel fire. The delivery system was just as mysterious and advanced. It wasn't thrown in a pot, it was projected. Texts and illustrations describe a pressurized siphon, a complex tube-like device mounted on the prows of Byzantine dromon warships. Operators would pump the device, and a stream of fire would lance out across the water to strike enemy vessels with terrifying precision. This was not a weapon of chance. It was a precise instrument of war, requiring specialized training and equipment. So what was this mysterious substance? While the exact formula died with the Byzantine emperors who guarded it as a state secret more valuable than gold, modern chemists and historians have pieced together a highly plausible reconstruction based on the clues. The base fuel was almost certainly a form of crude oil or naphtha, a light petroleum product that could be skimmed from natural oil seeps in the region. The Byzantines wouldn't have understood modern petroleum distillation, but they would have understood through experimentation that some oils burned more fiercely and were more liquid than others. This raw naphtha was likely mixed with other combustible materials like resin or sulfur to make it thicker and stickier, ensuring it would cling to whatever it touched. But the true genius, the ingredient that gave Greek fire its infamous water-resistant property, was probably quicklime. This compound, made from heated limestone, has a fascinating property. It reacts exothermically with water, releasing a great deal of heat. If quicklime was powdered and added to the naphtha mixture, Any attempt to douse the flames with water would only make the reaction hotter and more intense, creating the terrifying effect of fire that water could not quench. The mixture would have been stored in heated, pressurized barrels to keep it in a liquid state until the moment it was unleashed through the bronze siphon, which may have used a forced air pump or a chemical ignition system to ignite the stream as it left the nozzle. This re-evaluation is monumental. It transforms Greek fire from a mythical legend into the world's first true chemical weapon system. It reveals a level of technological sophistication in medieval warfare that we rarely credit, a complex interplay of chemistry, engineering, and logistics. The Byzantines weren't just throwing fire, they were handling unstable, dangerous chemicals, maintaining pressurized systems, and employing precise deployment tactics. This was a technology that required a deep, albeit empirical, understanding of chemical properties and reactions. It predates the widespread use of gunpowder in the West by centuries and stands as a terrifyingly advanced precursor to modern flamethrowers and even napalm. Its development underscores a recurring and often dark theme in human history, that some of our most profound scientific and engineering leaps are driven by the desperate need to defend ourselves or to gain an advantage in conflict. The ambition to create a more effective weapon can be a powerful catalyst for innovation, pushing the boundaries of materials science, physics, and chemistry in ways that peaceful pursuits sometimes do not. The most enduring mystery of Greek fire is not just its composition, but the fact that its secret truly did die. The Byzantine emperors were so paranoid about this technological advantage falling into enemy hands that they compartmentalized its production ruthlessly. Legend says the formula was discovered by a Syrian architect named Kallinikos and presented to the emperor, and from that moment on, its manufacture was restricted to a single, trusted family who worked in utter secrecy, perhaps even within the palace itself. The components were likely sourced from different, unrelated suppliers to prevent anyone from reverse engineering the complete recipe. This extreme level of security was ultimately too effective. When Constantinople finally fell to the Ottomans in 1453, the secret keepers presumably died with their city, and the formula vanished forever. This ultimate loss is a poignant lesson in the fragility of knowledge. It shows that technology is not a guaranteed, ever-accumulating ladder. It can be a branching tree, and branches can be lopped off, sometimes deliberately, by the very hands that nurtured them. The story of Greek fire is a thrilling tale of ancient innovation, but it is also a solemn warning, a reminder that when knowledge is hoarded as power instead of shared as understanding, it risks being lost to the world forever, leaving behind only the echo of its terrible, awesome roar across the water. Leaving behind the searing terror of Greek fire, we journey now to a landscape of immense silence and breathtaking scale, where an entire civilization chose to write its secrets not on parchment or stone, but on the very skin of the earth itself. Scratched into the sun-baked, rust-colored plains of southern Peru, the Nazca Lines are one of archaeology's most iconic and enduring puzzles. From the ground, they are nearly invisible shallow grooves in the desert pavement, no more than a foot deep. But from the air, they transform into a breathtaking gallery of colossal art. A hummingbird with wings outstretched, a spider with perfectly articulated legs, a monkey with a spiraling tail, and vast geometric shapes stretching for miles across the desert floor. For nearly a century after their modern discovery by pilots in the 1920s, the prevailing theories about these geoglyphs were almost exclusively mystical. They were seen as astronomical calendars aligned with constellations, sacred pathways for religious processions, or perhaps even landing strips for ancient astronauts, a canvas for the gods, drawn on a scale only visible from the heavens. This interpretation fit a comfortable pattern, reducing a complex ancient culture to a society of star-gazing mystics, their immense effort dedicated solely to the spiritual realm. But this view always contained a fundamental flaw. It ignored the brutal, practical reality of the environment in which the Nazca people lived and thrived. The Nazca Desert is one of the driest places on Earth, a hyper-arid landscape where rain might not fall for years at a time. Yet, the Nazca culture flourished here for over a millennium, supporting a population of thousands. They built cities, developed a vibrant artistic tradition with beautiful ceramics and textiles, and maintained a complex society. This paradox, a prosperous civilization in a place with almost no visible water, demanded a practical explanation. How did they survive? The answer, it turns out, might have been etched right beneath our feet all along. A growing body of research, led by hydrologists and archaeologists working together, is converging on a revolutionary theory. The Nazca Lines were not just art for art's sake. They were an integral, functioning part of a sophisticated and sustainable water management system, a survival technology written in the language of symbolism and geography. The mechanics of this system are as ingenious as they are beautiful. The Nazca didn't rely on rivers or rainfall. They tapped into a far more reliable source, underground aquifers. Their water came from the Andean mountains to the east. During the rare periods of rain high in the mountains, water would trickle down through the rock and gravel, traveling for miles underground before being forced to the surface in certain areas by the geological structure of the Nazca Valley. The key to harnessing this resource was finding THESE Chinese letter, these points where the water emerged. This is where the lines and geoglyphs come in. Researchers like David Johnson have proposed that the long, straight lines and trapezoidal shapes act as giant arrows or markers, pointing directly toward sources of subterranean water. A vast trapezoid might lead to a small spring at its narrow end, while a series of straight lines could converge on a critical well or a fault line in the bedrock where water was close to the surface. The famous animal figures, then, might have served a different but related purpose. They could have been ritual symbols associated with water and fertility. The hummingbird, the monkey, the whale placed at specific, hydrologically significant locations to mark them as sacred and vitally important. In this interpretation, the spiritual and the practical are not separate. They are two sides of the same coin. A ceremony performed on a line leading to a water source wasn't just a prayer for rain. It was a communal act of maintaining and celebrating the infrastructure that made life possible. The evidence supporting this theory is both physical and logical. Satellite imaging and geological surveys have repeatedly shown a strong correlation between the placement of the geoglyphs and the location of underground aquifers and wells. Furthermore, the very technique used to create the lines reveals a deep understanding of the desert itself. The Nazca didn't just dig randomly. They carefully removed the top layer of dark, sun-heated stones to reveal the lighter, clay-rich soil beneath. This wasn't merely for visual contrast. This lighter subsoil had a different density and porosity. During the occasional early morning fog that rolls in from the ocean, known as garua, this exposed soil would absorb moisture more effectively than the surrounding desert pavement. The lines would act as subtle traps for this precious moisture, helping to prevent evaporation and perhaps even channeling tiny amounts of water downward to replenish the very aquifers they depended on. It was a multi-layered hydroengineering project. The large figures and lines marked the water sources, while the physical act of creating them also helped to conserve the water itself. This reclassification fundamentally changes our understanding of the Nazca. They were not a people simply hoping for divine intervention from the sky. they were pragmatic hydraulic engineers who read the landscape with an expert eye. They understood geology, the flow of water through rock, and the subtle hydrology of their desert home on a level that allowed them to transform an inhospitable environment into a livable one. Their greatest artistic achievement was also their most vital piece of civic infrastructure, a map, a manual, and a monument to survival all in one. The Nazca Lines stand as a powerful testament to human ingenuity, proving that the drive to create beauty and the need to solve practical problems are often the very same impulse, a way of weaving the sacred into the fabric of everyday survival and leaving a message of resilience that we are only now beginning to read. Moving from the vast desert canvases of the Nazca, we now turn our attention to a far more intimate and handheld mystery, one that has baffled experts for generations not because of its scale, but because of its perfect, perplexing geometry. Scattered across the far-flung provinces of the former Roman Empire, from the misty borders of Britain to the sunny coasts of Hungary, archaeologists have unearthed over 100 of these enigmatic objects. Each one is a small, hollow, bronze dodecahedron, a 12-sided solid with each face being a perfect pentagon. Every face has a circular hole of a different diameter, and at each of the 20 points where the sides meet, there is a small knob or ball. They are exquisitely crafted, showing no signs of wear or tool marks, and they range in size from a golf ball to a large fist. For centuries, the official classification was comfortably vague. They were ritual objects, perhaps used in mystical practices, or maybe they were simply decorative finials for furniture or staffs. A curious but ultimately unimportant oddity from the Roman world, their true purpose lost to time and filed away under unknown. But this tidy classification has never sat well with everyone. The sheer number of them found across such a wide geographic area suggests they were not rare cult objects. More importantly, their construction hints at something far more practical. They are not crudely cast, they are precision-made, with the holes on each face being meticulously sized and placed. This isn't the work of a local blacksmith making a trinket. This is the work of a skilled metalsmith creating a standardized object. The holes are not random, they follow a pattern, and the knobs are consistently placed. This level of geometric precision and standardization is the hallmark of a tool, not a toy. It whispers of calibration, of measurement, of a specific, repeatable function that was important enough to be replicated across the entire empire. The old ritual object label began to feel like a cop-out, a placeholder for an answer that was waiting for a more imaginative question. This has led to a fascinating explosion of modern theories, each one attempting to crack this ancient code by imagining the object in use. One of the most compelling ideas is that they were sophisticated gauges or calibrators. A craftsman, perhaps a blacksmith or a carpenter, could have used the different-sized holes to standardize the diameter of metal rods, wooden dowels, or even leather straps. This would have been crucial for the mass production of interchangeable parts for the Roman military machine, ensuring that a wheel axle made in Gaul would fit perfectly onto a cart made in Italy. The knobs on the corners could have been used to hold the device steady or to attach it to a base. Another ingenious theory proposes they were geometric calculators for engineering and construction. By threading string through the different holes and wrapping it around the knobs, a user could create complex geometric shapes and calculate angles vital for surveying land, building aqueducts, or designing complex architecture. The dodecahedron itself is a shape rich with mathematical properties, and it's not a stretch to imagine Roman engineers harnessing its form for practical calculation. The range of other proposed uses is a testament to both human creativity and the object's enduring mystery. Some have suggested they were knitting tools for creating complex fingerless gloves, with the knobs acting as a form for the knuckles. Others have theorized they were range-finding devices for the Roman artillery, the ballistae. A soldier could peer through the different holes to estimate the distance to a target based on its apparent size. There's even a theory that they were candlestick holders, with the different hole sizes accommodating candles of varying thicknesses. While some of these ideas are more plausible than others, they all share a common thread. They treat the dodecahedron not as a sacred object, but as a piece of technology. This shift in perspective is everything. It moves the conversation from "what did they believe" to "what did they do?" It forces us to see the Romans not just as conquerors and builders, but as meticulous engineers, systematizers, and problem solvers who valued precision in every aspect of their world. The ultimate lesson of the Roman dodecahedron may not be about finding a single, definitive answer. Its power lies in its ambiguity. It is a perfect symbol of the gap between the ancient world and our own. It represents a piece of common knowledge so fundamental to daily Roman life that no one ever thought to write down its purpose. It was as obvious to them as the function of a spanner or a tape measure is to us. Its very existence is a humbling reminder of how much practical, tacit knowledge has been lost. We can reconstruct their battles from histories, their politics from letters, and their diets from trash heaps, but the silent, clever tools of the everyday artisan often leave no written record. The dodecahedron challenges us to fill in that silence with our imagination, to look at a beautifully made bronze object and see not a ritual symbol, but the well-oiled, mathematically precise, and brilliantly pragmatic engine of an empire that ran on standardization. It is a ghost of a technology, a puzzle that may never be definitively solved, and in that uncertainty, it tells us more about the sophisticated, organized, and ingenious mind of Rome than 1,000 clearly labeled artifacts ever could. While the Roman dodecahedron represents a mystery of mundane precision, our next artifact catapults us into the realm of cosmic awareness and imperial responsibility, showcasing an invention so advanced that its very existence was debated for centuries. In the year 132 of the Common Era, during the illustrious Han Dynasty, a brilliant polymath named Zhang Heng presented the emperor with a device that seemed to border on magic. Ancient texts describe a magnificent bronze urn, adorned with 8 dragons snaking down its sides, each one clutching a bronze ball in its jaws. Below each dragon sat a corresponding bronze toad with its mouth open, ready to receive. The account claimed that when an earthquake occurred, even hundreds of miles away, a mechanism inside the urn would be triggered. One of the dragons would release its ball, which would clatter into the mouth of the toad below with a loud and unmistakable ring, not only signaling that a quake had happened, but also indicating the precise direction from which the seismic waves had originated. To later scholars, especially those in the West who encountered the story centuries after the fact, this sounded less like science and more like allegory or myth, a poetic fable about imperial omens rather than a description of a functioning machine. The idea that a 2nd century inventor could detect distant ground motions he couldn't even feel was simply too fantastical to be believed, and so Zhang Heng's Seismoscope was quietly filed away in the history books as a curious legend, a testament to human imagination rather than engineering prowess. This skepticism persisted for nearly 2 millennia, a classic case of judging the past through the narrow lens of contemporary understanding. The downfall of the device was its own sophistication. Its internal mechanism was not described in detail in the surviving texts, leaving a gap in knowledge that seemed impossible to bridge. How could a sealed vessel possibly sense a tremor from another province? Without a clear blueprint, historians defaulted to the simplest explanation. It must have been a clever hoax or a piece of court theater. perhaps with a hidden servant inside tipping the balls at the right moment. This dismissal, however, failed to account for the well-documented credibility of its inventor. Zhang Heng was no court jester or mystic. He was the imperial astronomer, a mathematician, cartographer, and one of the most renowned scientists of his age. He built a working model of the cosmos with an armillary sphere and made precise astronomical observations. To him, the seismoscope was not magic, it was applied physics. The key to unlocking his secret was to stop looking for a detailed instruction manual and start applying the principles of mechanics that he would have understood. The turning point came when modern engineers and historians began to take the textual fragments seriously and attempted to reverse engineer the device based on the known scientific principles of the time. The most successful reconstructions, particularly one developed in the 20th century by a team including a British seismologist, focused on a simple but brilliant principle: inertia. The central idea is that the urn contained a heavy, inverted pendulum suspended from the top. When seismic waves, specifically the faster-traveling P waves that arrive, first pass through the ground and into the vessel, they would cause the entire urn to shift slightly. The suspended pendulum, however, thanks to inertia, would tend to stay in place. This relative motion would act as the trigger. The top of the pendulum was likely connected to a set of levers or arms that were delicately balanced near the mouths of the 8 dragons. A slight swing in one specific direction would push against one of these levers, which would in turn dislodge a catch holding the ball in that dragon's jaw. The beauty of the system is its elegant simplicity and its profound understanding of wave mechanics. It didn't just detect shaking. It detected the direction of the initial energy pulse, which is the fundamental basis of modern seismology. The true test, of course, was whether such a reconstruction would actually work. In 2005, a team of scientists in China built a precise replica based on this pendulum and lever design and put it to the test using simulated waves from historical earthquakes that Zhang Heng himself was recorded to have detected. The results were stunning. The replica successfully detected the simulated quakes and indicated the correct direction of the epicenter every time. It wasn't just a theoretical model, it was a functional, sensitive, and reliable scientific instrument. This empirical validation was the final nail in the coffin of the legend theory. Zhang Heng's device was real, and it worked exactly as the ancient histories said it did. This single experiment transformed the seismoscope from a myth into the world's first known seismometer, a piece of technology that would not be rivaled in the West for over 1,500 years. This reclassification does more than just add an early chapter to the history of geology. It fundamentally reshapes our understanding of ancient Chinese science and the motivations behind technological innovation. The seismoscope was not built in a vacuum. It was a tool of governance. China, a vast empire prone to devastating earthquakes, needed a way to quickly respond to disasters. A quake in a distant province could take weeks to be reported by messenger on horseback, delaying critical aid and allowing rebellions to foment under the assumption that the emperor had lost the mandate of heaven. Zhang Heng's invention provided an almost instantaneous alert system. The loud clang of the bronze ball in the palace courtyard was a call to immediate action, allowing the central government to dispatch aid and officials to the affected region with unprecedented speed, demonstrating the emperor's benevolent power and maintaining stability. This reveals a society that viewed scientific advancement not as abstract curiosity, but as a practical tool for social order, disaster management, and effective rulership on a continental scale. The sophistication embedded in the device is perhaps its most breathtaking aspect. To create a directional sensor, Zhang Heng must have possessed a deep, intuitive understanding of wave propagation and the vector nature of forces. He knew that the energy from an earthquake travels outward in a predictable way and that the first tremors to arrive could reveal the source. This conceptual leap is monumental. It means that a thinker in the 2nd century was grappling with the same fundamental principles that would only be formally described by European scientists in the 18th and 19th centuries. The seismoscope stands as a lonely pinnacle of achievement, a glimpse of a path of scientific inquiry that was centuries ahead of its time. It forces us to ask a haunting question: how many other brilliant inventions, how many other flashes of insight were lost because they were too far ahead of their time to be properly understood, maintained, and built upon? Zhang Heng's dragon urn is more than a relic. It is a monument to a forgotten timeline of science, a single, perfect day to point proving that the spark of genius can flare up anywhere, in any era, often leaving the rest of the world to spend centuries catching up to its light. From the precise mechanics of Zhang Heng's earthquake detector, we now turn to an artifact whose story is not one of rediscovered genius, but of manufactured mystery, a cautionary tale carved in crystal. The legend of the crystal skulls is a seductive one, perfectly sculpted from a single block of clear or milky quartz. These hauntingly beautiful objects were said to be the work of ancient Mesoamerican civilizations like the Maya or Aztec. They were attributed with mystical powers, from healing and telepathy to holding the secrets of Atlantis and other lost worlds. For over a century, they captivated the public imagination, featured in museum displays and sensational books as enigmatic relics of a forgotten, advanced age. Their flawless surfaces and impossible precision seem to defy the technological capabilities of the pre-Columbian world, making them perfect fodder for theories that stretched far beyond conventional archaeology into the realms of the extraterrestrial and the occult. They were, in every sense, the ultimate out-of-place artifacts, seemingly impossible objects that demanded an extraordinary explanation. This romantic narrative began to unravel under the cold, hard gaze of 20th century science. The first major crack appeared with a detailed study of the most famous specimen, the Mitchell-Hedges skull, named after the adventurer who claimed to have discovered it in a Mayan temple in Belize in the 1920s. When researchers finally gained access to examine it with modern tools, the story fell apart. Microscopic analysis revealed something a Mayan artisan could never have possessed: the telltale marks of high-speed, rotary lapidary wheels and polishing compounds infused with industrial diamonds, technologies that simply did not exist in the Americas before European contact. The skull hadn't been patiently ground and polished with sand and water over generations. It had been manufactured with the precision tools of the 19th century. This wasn't an isolated case, as other major crystal skulls in museums like the British Museum and the Smithsonian Institution were subjected to similar scrutiny. The results were identical. Each one bore the microscopic signature of modern jewelers' tools. The conclusion was inescapable and unanimous. These were not ancient treasures. They were modern fakes, likely crafted in Europe between the 1860s and the 1890s. The real mystery, then, is not the origin of the skulls, but the origin of the myth. Why were they created, and why were they so eagerly believed? The answer lies in the unique cultural climate of the 19th century. This was the era of burgeoning museums, world's fairs, and a voracious public appetite for the exotic and the ancient. It was also the height of European colonialism, a time when Western nations were plundering the world for artifacts to fill their new institutions and validate their sense of cultural superiority. This created a perfect storm of supply and demand. Skilled lapidaries, particularly in Germany's Idar-Oberstein region, a world center for gem carving, found a lucrative market producing antiquities for wealthy collectors and curators who were more passionate than discerning. These carvers were not crude fraudsters. They were immensely talented artists pushing their craft to its absolute limits, creating objects of stunning beauty and technical mastery. The irony is profound. The very perfection that made the skulls seem mystical and ancient to their buyers was actually the proof of their modern, industrial-era origins. The enduring power of the Crystal Skull legend speaks to a deep and powerful human need, the desire for a past that is more mysterious, more magical, and more advanced than the one we know. We are drawn to the idea of lost wisdom and fallen civilizations because it suggests that our own history is richer and more complex than the sometimes grim archaeological record of human struggle. The skulls tapped into a romanticized view of indigenous cultures as spiritually profound and mystically connected to secrets that modern science had forgotten. This narrative was often more appealing than the reality, and it was eagerly consumed by a public looking for enchantment in an increasingly industrialized and rational world. The skulls became blank canvases onto which people could project their own beliefs about Atlantis, psychic powers, and ancient astronauts, their smooth, reflective surfaces offering no argument, only a silent, inviting mystery. In the end, the crystal skulls are far more fascinating as artifacts of the 19th century than of any mythical ancient era. They are cultural relics in their own right, revealing volumes about the time that created them. They tell a story of technological pride in European craftsmanship, of the complex and often exploitative relationships between colonizers and the colonized, and of the birth of a modern media culture capable of generating and sustaining a global myth. They serve as an eternal cautionary tale for archaeologists and historians, a reminder that authentication is not a mere formality but the very foundation of the field. The story of the crystal skulls teaches us to question the extraordinary claim, to demand evidence over allure, and to remember that the most seductive mysteries are not always the oldest ones. Sometimes the greatest deception is not hidden in the distant past, but crafted in a well-lit workshop, waiting for us to project our own dreams onto its perfectly polished surface. Buried under the ashes of a catastrophic fire that consumed the Minoan palace of Feistos around 1700 years before the Common Era, a most peculiar object lay waiting for 35 centuries. When Italian archaeologist Luigi Pernia unearthed it in 1908, he knew he was holding something unique. It was a small, fired clay disc, roughly the size of a standard dinner plate, and its entire surface was covered on both sides with a spiraling sequence of mysterious symbols. There were men running and women dancing, ships and shields, birds and bees, all stamped into the clay with a clarity and consistency that was immediately striking. In a world of hand-painted frescoes and intricately carved seals, this was different. This was a document of mass production, a message meant to be replicated, yet it was the only one of its kind ever found. Faced with this beautiful enigma, the academic world did what it often does with the unfamiliar. It filed it away under a safe, if unsatisfying, category. For decades, the prevailing theory was that it must be a religious hymn or a prayer, a sacred text for some forgotten ritual. Others dismissed it as an elaborate board game, an ancient trifle not worthy of serious scholarly pursuit. It was easier to relegate it to the realms of the ceremonial or the leisurely than to confront the far more radical possibility it presented. This comfortable classification began to fracture with the dawn of the digital age. As computational power grew, so did our ability to analyze the disk's 45 distinct signs, arranged in 241 impressions across 61 words, all spiraling inward from the rim. Researchers from fields far outside archaeology, linguists, cryptographers, and computer scientists began to apply their tools to this ancient puzzle. They weren't just looking at the symbols as art, they were analyzing them as data. They searched for patterns, repetitions, and syntactic structures that might reveal an underlying language. While the script itself remains undeciphered, the results of these computational analyses have been nothing short of revolutionary. The arrangement of the symbols doesn't follow the random patterns of art or the simple repetitions of a basic chant. It displays a combinatorial structure, a deliberate sequencing that strongly suggests it encodes a genuine language, complete with a structured grammar. This wasn't just a pretty picture, it was a text, and the method of its creation was the real bombshell. Each symbol was not drawn or carved. It was stamped into the soft clay with a pre-made seal, a piece of movable type. This single, simple fact sends a tremor through the entire foundation of technological history. Consider the staggering implication. For centuries, Johannes Gutenberg has been hailed as the revolutionary father of printing for his invention of the movable type press in the 1400s. His innovation is credited with democratizing knowledge, fueling the Renaissance, the Reformation, and the scientific revolution. It is, in many ways, the bedrock of the modern world. The Feisto's disk, if interpreted correctly, suggests that the core concept of movable type printing was not invented in 15th century Germany, but was discovered, utilized, and then lost in the Bronze Age Mediterranean over 3,000 years earlier. This isn't just a matter of moving a date back on a timeline. It fundamentally alters our understanding of the Minoan mind. It paints a picture of a society that valued the replication and standardization of information on a scale we never imagined. They weren't just artists and traders, they were information technologists. They sought a way to move beyond the painstaking, one-of-a-kind creation of scribes and create a system for producing multiple, identical copies of a text quickly and efficiently. The disk itself might be a unique copy, but the technology behind it, the set of 45 individual stamps, implies a system designed for repetition. This leads to the haunting question of purpose. What message was so important, so necessary to replicate, that it justified the immense effort of creating a full set of type? Theories abound, each more fascinating than the last. Perhaps it was a royal proclamation or a legal code, intended to be sent to various cities across the Minoan thalassocracy, ensuring a consistent law was read in every town square. Maybe it was a religious text, a standardized hymn to be sung in palaces and peak sanctuaries to unite the people under a common spiritual banner. Some have even proposed it was a cryptographic device, an early cipher for encoding military dispatches or diplomatic messages to protect secrets from prying eyes. The very fact that we can plausibly entertain these ideas shatters the image of Bronze Age kingdoms as simple, hierarchical states. It suggests an administrative complexity, a need for long-distance communication, and consistent messaging that we typically associate with much later empires like Rome. The ultimate mystery of the Feisto's disk is not just what it says, but why its technology appears to be a dead end. If the Minoans had this brilliant idea, why didn't it spread? Why is there no Feisto's disk 2 or 3? The answer likely lies in the fragile nature of civilization itself. Shortly after the disk was made and fired, the palace of Feistos was burned to the ground, part of a wider collapse that swept across the Mediterranean, toppling the Minoan and Mycenaean palaces and plunging the region into a dark age. Literacy vanished, complex technologies were forgotten, and the intricate networks of trade and ideas that could have spread this innovation were severed. The knowledge of movable type may have perished in that very fire, a single, bright spark of genius that was snuffed out almost as soon as it was lit, leaving behind one perfect, fired clay specimen as a tantalizing glimpse of a path not taken. It stands as a profound lesson in the fragility of progress, a reminder that technological advancement is not a guaranteed, ever upward climb, but a precarious journey where brilliant ideas can be lost for millennia, waiting in the ashes for a future age to finally understand what they were looking at all along. Imagine a single, worn silver coin, smaller than a thumbnail, unearthed from a mound of shells and animal bones in a quiet coastal dig in Maine. This unassuming object, a Norse penny dating to the reign of King Olaf Kyrre between 1066 and 1080, would become the epicenter of one of American archaeology's most heated and enduring debates. Discovered in 1957 at the Goddard site, a well-documented Native American trade village, the coin was such an unbelievable outlier that the immediate, almost reflexive reaction from the academic community was outright dismissal. It had to be a hoax, a plant, a practical joke by a mischievous excavator. Perhaps it was a later trade item dropped by a European colonist centuries after its minting and somehow worked its way into older layers. The idea that it could be genuine evidence of a Viking presence was for many a bridge too far. The established narrative was clear and comfortable. Christopher Columbus was the first European to reach the New World in 1492. A solitary coin without context was not enough to topple that monument. It was labeled an anomaly and contamination, its story suppressed by the weight of conventional history. For decades, the Maine penny languished in this scholarly purgatory, a curious footnote mentioned with skepticism. The tide began to turn not because of the coin itself, but because of a parallel revolution happening thousands of miles away. In the 1960s, a Norwegian husband and wife team of adventurers, Helge and Anne Stein Ingstad, followed a hunch from the Viking sagas to the northernmost tip of Newfoundland. There, at a place called Elance Orks Meadows, they began to excavate and uncovered something earth-shattering, the unmistakable remains of a Norse settlement. They found the foundations of Viking longhouses, a forge for smelting iron, and artifacts like a bronze cloak pin that were indisputably Norse in origin. This wasn't a theory anymore. It was a fact confirmed by radiocarbon dating to around the year 1000. The Vinland of the sagas was real. This monumental discovery provided the crucial context the Maine penny so desperately needed. It was no longer a lonely, implausible outlier. It was now a piece of a puzzle that was slowly, definitively falling into place. If the Norse had a base camp in Newfoundland, was it really so far-fetched that their explorers, traders, or hunters might have ventured further down the coast? The journey of this little coin from Norway to Maine is a story written in wind, water, and wood. We must picture a Norse Nar, a sturdy, ocean-going cargo ship sailing west from Greenland. These were not the serpent-prowed longships of raiding fame, but broader, deeper vessels built for carrying settlers, livestock, and trade goods across the treacherous North Atlantic. The navigational skill required for this voyage cannot be overstated. Without compasses, these sailors used a profound knowledge of seabirds, whale migration patterns, the color of the water, and the position of the stars and the sun, perhaps even aided by those now confirmed sunstones, to find their way. A voyage from their Newfoundland camp at Elance Orks Meadows down the coast of what is now Canada and into the Gulf of Maine would have been a logical exploration. They were seeking valuable resources mentioned in the sagas, timber, furs, and perhaps even grapes. The Goddard site in Maine was a thriving hub of the red paint people, a sophisticated indigenous culture known for its extensive trade networks that stretched far inland. A Norse party, whether by design or accident, could have easily made contact here. This is where the coin transforms from evidence of travel into evidence of connection. The most plausible explanation is not that a Viking dropped his wallet. A single coin, especially one from a century earlier, would have had little monetary value to a Norse trader in the New World. Its value was likely intrinsic and symbolic. It was a piece of worked silver, a shiny, exotic object. It fits perfectly into the pattern of what we know about early cultural encounters across the world. The Norse would have engaged in silent trade or direct barter with the indigenous inhabitants, offering bits of metal, cloth, or tools in exchange for valuable furs and provisions. To a Native American artisan, this Norse penny would have been a marvelous curiosity. It could have been punched and strung into a necklace, traded far inland along well-established routes, or kept as a talisman. Its discovery amidst a vast midden of processed clams and bones suggests it was not a cherished central treasure, but a lost item, something that slipped through a hole in a pouch or was casually discarded after its novelty wore off. This mundane context makes it more credible, not less. It feels like a genuine accident of history, not a planted clue. The reclassification of the main penny is therefore about so much more than just changing a label in a museum catalogue. It represents a fundamental shift in our understanding of the medieval world. For centuries, the story of exploration was a simple, Eurocentric tale of a pre-Columbian void suddenly filled by Columbus in 1492. The penny, supported by Eland's ox meadows, shatters that simplicity. It reveals a world that was more connected, more curious, and more dynamic than we ever knew. It shows that the first chapter of transatlantic contact was not one of conquest and colonization, but of tentative, likely small scale, and probably intermittent exchange. It pushes the start date of globalization back by 500 years, proving that the oceans were not impassable barriers but highways for the boldest of sailors. This single coin is a testament to the fact that history is not a straight line of progress but a complex web of intersections, some of which are only visible once we are willing to look for them, to take a small piece of silver not as an error but as an invitation to rewrite the map. And so we arrive at one of the most infamous and widely circulated tales in the annals of alternative history, a story that perfectly encapsulates how a potent mix of desire and deception can create a modern myth that proves almost impossible to dislodge. The legend of the Dropa stones begins in a remote and dramatic setting, the Bayan Ha Mountains on the border between China and Tibet. In 1938, a Chinese archaeologist named Kai Pu Te claimed to have discovered a series of caves containing neat rows of ancient graves. The skeletons within were described as bizarrely small and fragile, with unusually large, oversized skulls. But the truly extraordinary find was scattered across the cave floor, hundreds of stone discs, roughly 9 inches in diameter, each with a perfect spiral groove originating from a hole in the center, much like a primitive phonograph record. The story goes that when these discs were later examined in the 1960s, a professor named Tsum Nui found that the grooves were not decorative at all, but actually an impossibly tiny form of writing, a microscopic script that told an astonishing story. The hieroglyphics allegedly recounted the tale of a spaceship that crashed in the mountains millennia ago, piloted by a race of beings called the Dropa. Unable to repair their vessel, they were stranded on Earth and were eventually killed by the local tribespeople. The stones were their recorded history, a plea for understanding from a lost extraterrestrial civilization. It was the ultimate ancient astronaut narrative, a perfect, self-contained artifact that seemed to provide tangible, physical proof for a theory that was capturing the public imagination. The appeal of this story is immediately obvious. It has all the elements of a perfect science fiction plot: a remote, mysterious location, strange non-human skeletons, and a technologically advanced artifact that holds a secret message. For decades, this tale was repeated in books, magazines, and documentaries dedicated to the unexplained. It was presented not as a legend, but as a suppressed archaeological fact, evidence that mainstream science was ignoring because it was too uncomfortable, too paradigm-shattering to accept. The Dropa stones became a cornerstone of the ancient alien hypothesis, a seemingly unassailable data point that proved we were not alone in the universe and that our history was far stranger than anyone dared admit. They tapped directly into a deep and growing cultural undercurrent of distrust for institutional authority and a longing for a cosmos filled with wonder and mystery, a universe where the lonely Earth was just one stop on a vast interstellar highway. The stones were the ultimate what-if, and for a time they were accepted by millions as a genuine, if unverified, mystery. The unraveling of this compelling story is a masterclass in the painstaking and often thankless work of scientific skepticism. Investigators who went looking for the primary sources found only a gaping void. There were no credible academic papers by Kai Pute or Tsumam Nui published in any recognized archaeological or scientific journal. The very existence of these professors was called into question, with no independent records of their work or affiliations. The claims about the microscopic writing were always second or third hand. No one could produce a clear, close-up photograph of the alleged script, and no reputable epigrapher or linguist was ever given the opportunity to examine the discs. The few grainy, long-distance photos that circulated in publications were utterly unconvincing, showing objects that looked suspiciously like common stone by discs, well-known funerary items from ancient China that sometimes feature spiral patterns but are purely ceremonial and contain no writing whatsoever. The entire narrative was built on a foundation of hearsay, unattributed quotes, and a complete lack of physical evidence available for peer review. The most definitive debunking came from a practical and geological perspective. When researchers finally tracked down objects purported to be Dropa stones held in private collections, they were able to conduct proper analyses. The results were unequivocal. The stones were identified as a common type of metamorphic rock, and the famous grooves were not cut or carved by any tool. They were natural mineral veins of a different colored material, typically serpentine or chlorite, that had crystallized in a radial, spiral pattern within the surrounding stone. This is a well-documented and entirely natural geological phenomenon. Furthermore, the idea of microscopic writing being carved into such a hard stone with primitive tools was dismissed as a physical impossibility. Even with modern laser technology, such an endeavor would be incredibly difficult. The story wasn't just unverified, it was physically implausible from the start. The most likely origin for the entire saga is a cultural game of telephone that began with a real but misinterpreted archaeological find of common by discs and unusual skeletal remains, perhaps of a small-statured local tribe, that was then sensationalized and embellished by a journalist or author, with each retelling adding a new layer of extraterrestrial detail until the original facts completely obscured by a much more appealing fiction. The enduring legacy of the Dropa stones, therefore, has nothing to do with ancient astronauts and everything to do with modern psychology. This case is a perfect specimen for studying how myths are born and why they persist. It demonstrates our powerful cognitive bias toward confirmation, the tendency to embrace evidence that supports what we already want to believe and to ignore or explain away evidence that contradicts it. For those already inclined to believe in ancient extraterrestrial visitations, the Dropa story was a gift, a ready-made piece of evidence that required no critical examination. It also highlights the potent role of narrative. A dry, scientific paper about mineral crystallization is forgettable. A thrilling story of a crashed spaceship and a doomed alien race is unforgettable. The human brain is wired for story, and a good story will always have more gravitational pull than a mundane fact. Ultimately, the Dropa stones serve as one of the most important artifacts on our list, not for what they reveal about the past, but for what they reveal about ourselves. They are a monument to the critical need for healthy skepticism and intellectual rigor. They remind us that the burden of proof always lies with the person making the extraordinary claim, and that claims made without evidence can be dismissed without evidence. In a world increasingly saturated with misinformation and manufactured realities, the lesson of the Dropa stones is more vital than ever. They teach us to ask for the primary source, to question the motive of the storyteller, and to understand that the most satisfying explanation is not always the true one. They are a permanent caution carved not in stone, but in the collective memory of a field that must constantly guard against the seductive power of a good story over the hard, often less glamorous work of truth. Now, let's set our course for the wild, windswept shores of New Zealand, where a discovery that began as a simple curiosity would slowly unravel to reveal a map of the ancient world far more vast and interconnected than any historian had ever dared to draw. In the mid-19th century, a missionary was clearing land on a remote northern beach when his plow struck something hard and metallic. He unearthed a heavy, corroded bell, not unlike the kind that might hang in a European church tower. But when he cleaned it off, he found himself staring at a script that was utterly alien to this corner of the world. It was not Maori, the language of the island's inhabitants, and it certainly wasn't English. The bell was shipped off to a museum in Wellington, where it was catalogued as an oddity, a puzzling but ultimately isolated artifact. The most logical assumption was that it had come from a much later European shipwreck, perhaps a vessel that had traded in India and lost its cargo in a storm, allowing the bell to wash up on this distant shore. It was a comfortable explanation, one that kept the established historical narrative neatly intact. For nearly a century, that's where the story ended, a minor mystery quietly shelved. The turning point came when scholars finally took a closer look at the inscription itself. The script was definitively identified as Tamil, a language from the southern part of India, and it spoke of a specific community. The inscription referred to a ship's bell belonging to a vessel owned by the Musakapan, which translates to the ship's captain or a specific seafaring guild from a place called Patanam. This was not a generic object, it was a named artifact, a piece of maritime equipment with a clear provenance. Then came the dating. While the bell itself is difficult to date precisely, the style of the Tamil script placed it firmly in the medieval period, most likely from the 14th or 15th century. This single piece of information shattered the shipwreck theory. European ships did not begin regularly sailing these waters until the 17th century, with the arrival of the Dutch explorer Abel Tasman. This bell was at least 200 and possibly 300 years older than that. It hadn't fallen off a passing European galleon. It had arrived in New Zealand long before any European even knew the continent existed. This realization was like a crack of thunder, forcing a complete and radical re-evaluation of the object and the world it came from. So how did a 14th century Tamil ship's bell end up on a beach in New Zealand? The answer rewrites our understanding of medieval maritime ambition. We must picture not the familiar map of European exploration, but the vast, bustling network of the Indian Ocean world. For centuries, Tamil and other South Indian sailors had been the masters of the monsoon, building massive, multi-masted trading ships called thoni that could carry hundreds of tons of cargo. They dominated the routes from the coast of India to Southeast Asia, Arabia, and East Africa, trading in spices, textiles, gems, and ivory. Their navigational knowledge was profound, using star paths, wave patterns, and the flight of birds to cross open oceans. The presence of this bell suggests that some of these vessels, either by incredible design or desperate accident, ventured far beyond their known world. One compelling theory is that a trading ship was caught in a massive storm, a cyclone or a typhoon somewhere in the Indonesian archipelago. The powerful currents of the Pacific, like a giant aquatic conveyor belt, could have then carried the disabled vessel thousands of miles southeast, eventually depositing its shattered remains and this single bell on the coast of Aotearoa. It's a tale of disaster, but also one of astonishing seamanship, a testament to a vessel robust enough to survive such an ordeal, even if its crew did not. Another, even more fascinating possibility is that this was not an accident at all, but evidence of a deliberate, though perhaps undocumented, expansion of these trade networks. We know that Tamil influence extended all the way to Sumatra and Java. Is it so impossible to imagine that a captain, hearing tales from other sailors of rich, undiscovered lands to the south, decided to venture into the unknown in search of new resources or trading partners? The bell, after all, was not found in isolation. Its discovery correlates with other tantalizing clues. Sweet potatoes, a crop native to South America, found their way across the Pacific to become a staple in parts of Oceania well before European contact. The Maori themselves have oral histories that speak of ancient, light-skinned visitors. While these threads are speculative, the bell provides a hard, physical anchor point around which these possibilities can now be seriously considered. It suggests that the Pacific was not an empty void, but a space that was occasionally, and perhaps intentionally, traversed by the sophisticated mariners of other great seafaring cultures. The true power of the Tamil bell, therefore, lies not in its existence as a single object, but in what it represents, a world connected by threads of commerce and curiosity long before the age of Columbus or Vasco da Gama. It positions the Indian Ocean not as a closed system, but as a potential launching point for exploration into the greatest ocean on Earth. This single artifact forces us to dismantle the Eurocentric view of the Age of Discovery and replace it with a far more complex, multipolar map of global interaction. It reveals a medieval period pulsing with connectivity, where a merchant in Madras and a warrior in New Zealand were not living in separate, isolated worlds, but were potential participants in a chain of contact that stretched across a third of the globe. The bell is no longer a lonely curiosity. It is a key that unlocks a forgotten chapter of human ambition, a chapter written not in the ledgers of European kings, but in the language of the monsoon winds and the courage of sailors who followed them to the very edge of the known world, and perhaps just for a moment beyond. From the vast, interconnected world of the Indian Ocean trade routes, we now descend into a much smaller, but equally contentious, geological mystery, one that serves as a perfect case study in how a single object can become a lightning rod for our deepest desires to rewrite history. In the summer of 1936, a couple on a walk along the banks of Red Creek near the town of London, Texas, made a curious discovery. As the story goes, they spotted an odd piece of rock with a piece of wood protruding from it. When they cracked it open, they found what appeared to be a completely modern-looking hammer encased within. The hammer had a well-formed iron head and a wooden handle that was partially petrified, and it was all embedded in a hardened nodule of rock. The find was bizarre enough on its own, but its context would launch 1,000 theories. The rock surrounding it was identified as belonging to the Cretaceous period, a layer of ancient geology dating back over 100 million years, a time when dinosaurs roamed the Earth and humanity was not even a distant glimmer in evolution's eye. The immediate, sensational conclusion was obvious and irresistible. This was an out-of-place artifact, or UPART, definitive proof that modern humans, or at the very least a strikingly human-like technology, existed in the deep, deep past. This interpretation was a gift to alternative history and creationist circles. Here was an object that seemed to shatter the entire timeline of human evolution and technological development. If a hammer from the 19th century could be found sealed inside 100-million-year-old rock, then the established geological column must be completely wrong. Perhaps humans had existed alongside dinosaurs, just as some literal interpretations of certain texts suggested. Maybe it was evidence of time travel, a tool dropped by a careless visitor from the future. The hammer, which quickly became known as the London Hammer, was elevated from a local curiosity to an international icon. It was presented in books, documentaries, and museums dedicated to challenging mainstream science, held up as the ultimate smoking gun that proved experts had everything backwards. Its very existence was touted as evidence of a vast conspiracy within the scientific community to suppress findings that didn't fit the conventional narrative. The hammer became less of an artifact and more of a symbol, a rallying point for anyone who felt that the official story of our past was incomplete or deliberately misleading. The real story of the hammer, however, is not about its discovery, but about its eventual and thorough scientific dismantling. The key to unlocking the mystery wasn't a dramatic new theory, but a patient application of basic geological principles. The hard nodule that encased the hammer wasn't the pristine, 100-million-year-old Cretaceous bedrock it was initially claimed to be. It was a concretion, a very common type of rock that forms when mineral cement precipitates and hardens around a nucleus, often an organic object, in a process that can happen relatively quickly, especially in certain chemical environments. Geologists who examined the site noted that the area was rich in limestone and mineral springs. Water percolating through the ground would have leached dissolved minerals, particularly limonite, from the surrounding rock. When this mineral-rich water encountered the abandoned hammer, which was likely lost or discarded in the 19th century, it began to deposit those minerals around it, cementing it into a solid, stone-like shell. This process, known as concretion, does not require millions of years. Under the right conditions, it can occur in a matter of decades or centuries. The hammer wasn't breaking the rules of geology. It was perfectly demonstrating them. Further analysis of the hammer itself provided even more evidence for a modern origin. The iron of the head was found to be of a very consistent quality, with no slag inclusions, indicating it was produced by modern smelting techniques from the 19th century. The wooden handle, while partially mineralized, was not fully petrified and still contained traces of original organic material, which would have long since vanished if it were truly ancient. The most conclusive evidence came from a detailed examination of the concretion itself. It showed clear signs of being a localized phenomenon, not part of the in situ Cretaceous bedrock. It had likely formed in a pocket of soil and weathered material above the much older rock layer, and its discovery within that context was a simple case of misinterpretation. The hammer hadn't fallen through time. It had just been buried in a very chemically active spot that made it look far older than it actually was. The extraordinary claim had been defeated by a series of very ordinary, very well understood scientific explanations. The enduring legacy of the London hammer, therefore, has nothing to do with ancient civilizations or temporal paradoxes. Its true value is as a permanent lesson in the fundamental principles of scientific inquiry, specifically the concept known as Occam's razor. This principle advises that when presented with competing hypotheses, the one that requires the fewest assumptions is usually correct. The hypothesis that the hammer was a 19th century tool encased in a recently formed concretion requires only known, observable geological processes. The hypothesis that it is 100 million years old requires us to throw out everything we know about human evolution, metallurgy, and geology, and invent entirely new and unproven mechanisms for how it got there. The hammer reminds us that our first instinct when faced with a mystery should not be to reach for the most fantastical explanation, but to rigorously and skeptically search for the simplest one. It is a monument to the importance of context in archaeology and geology. An object without a clear and verifiable context is like a word without a sentence. Its meaning can be twisted to fit any narrative. The initial misclassification of the hammer's host rock led directly to decades of pseudoscientific claims, all because that one crucial piece of information was wrong. Ultimately, the hammer is a story about us. It reveals a deep and very human longing for mystery, for a past that is more dramatic and wondrous than the one painstakingly uncovered by decades of careful digging and analysis. It shows how easily we can be seduced by a story that feels true, that confirms our biases or our hopes, even in the face of overwhelming contradictory evidence. The London hammer doesn't prove that advanced ancient civilizations existed. It proves that we desperately want them to have existed. It stands as a humble, rusted testament to the idea that the real wonder isn't found in inventing fantastical stories about the past, but in possessing the intellectual honesty and discipline to uncover the truth, even when that truth is as simple and mundane as a lost tool slowly being swallowed by stone. Imagine an empire larger than Imperial Rome, stretching over 2,000 miles down the spine of the Andes, encompassing frozen peaks, dense jungles, and arid coasts, all without a single system of writing as we know it. For centuries, this was the central paradox of the Inca Empire, a mystery that led many early scholars to underestimate its complexity. How could such a vast territory, governing over 10 million people, be administered without the benefit of the written word? The answer was in plain sight, but we were looking at it all wrong. Hanging in storehouses and carried by swift-footed messengers called chasquis along the empire's famed road system were bundles of knotted cords known as quippes. To the Spanish conquistadors who encountered them, these objects were incomprehensible. They were dismissed as primitive tallying devices, simple mnemonic aids for remembering numbers, or perhaps even decorative trinkets. This fundamental misclassification, born from a cultural bias that equated literacy with intelligence, blinded us for generations to the true sophistication of one of the world's most unique information technologies. The key to cracking the code of the quipu was a shift in perspective, a move away from seeing it as a failed attempt at writing and toward understanding it as a successful and highly developed system of its own. A typical quipu consists of a main, horizontal cord from which multiple pendant cords hang. These pendants could themselves have subsidiary cords branching off, creating a complex, multi-level data tree. The information was encoded through a dazzling array of variables. The position of the knot on the cord, the type of knot used, a simple overhand knot, a figure 8, or a complex long knot, the spin and ply direction of the strings, and most strikingly, the color of the cords themselves. An empire's worth of data was stored in this intricate tapestry of cotton and wool. A red cord might represent the emperor or a soldier, yellow could signify gold, and green might denote a harvest of maize. The knots themselves were numeric, using a base 10 positional system remarkably similar to our own. A figure 8 knot represented the number 1. A long knot with a specific number of turns could represent the numbers 2 through 9. and the absence of a knot in a designated place signified zero, a concept the Inca grasped and utilized centuries before it became standard in European mathematics. This wasn't just counting, it was a structured, logical language of administration. For a long time, the dominant theory was that quippers were solely accounting tools, the spreadsheets of the Andes used to track tributes, census data, and warehouse inventories for the state. This is certainly a core part of their function, and evidence from the archaeological record strongly supports it. But a more radical and thrilling possibility has emerged from recent anthropological studies. When researchers began working with the descendants of the Inca in remote Peruvian villages, they found something astonishing: a living, albeit fragmented, memory of the quipu tradition. Elders in the community of Tupacasha still use simplified quippers to record contributions to local festivals and civic duties. More importantly, their oral histories speak of a time when quippers could do much more than record numbers. They could tell stories. These narratives, or quipu, were not read in a linear fashion like a book, but were recited by a trained specialist, a kipukamayak or keeper of the knots, who would run their fingers along the chords, feeling the textures and recalling the histories, genealogies, and laws encoded within. This transforms the quipu from a simple database into a potential narrative medium, a tactile library holding the very soul and history of a civilization. This revelation positions the quipu not as a primitive precursor to writing, but as a parallel invention, a different branch on the tree of information technology. In a world without paper or widespread literacy, the Inca developed a system that was perfectly adapted to their needs: portable, durable, and incredibly efficient. A messenger could run for miles with a quipu tucked into his belt, delivering complex data that would take pages of text to convey. In this sense, the quipu shares a conceptual kinship with modern computing. The binary code of ones and zeros that underpins all digital information is at its heart a system of on/off, yes/no states. The quipu operates on a similar principle of multi-variable coding: not/no not, this color/that color, this spin/that spin, to create a rich and complex information structure. It was a physical, three-dimensional database, a system of data storage and retrieval that challenges our most fundamental assumption that advanced civilization is impossible without phonetic writing. The Inca built and managed their empire not in spite of their unique system, but because of it. The tragic dimension of this story is the deliberate campaign of destruction that nearly erased this technology from history. The Spanish conquistadors and priests, viewing the quippers as idolatrous objects or tools of pagan sorcery, systematically sought out and burned them in vast bonfires. They understood, on some level, that these knotted cords were the central nervous system of the empire they sought to conquer, and to destroy them was to sever the Inca from their own memory, their own laws, and their own history. This cultural and informational genocide is why deciphering the narrative quippers remains one of archaeology's greatest challenges today. The living librarians who could read them were killed, and the keys to their deepest secrets were lost. The few hundred quippers that survive in museums are mostly the administrative ones, the dry ledgers of state that escaped the flames. The epic poems, the royal histories, the sacred myths, those libraries were almost entirely consumed. The story of the quipu is therefore a dual revelation. It is a breathtaking testament to human ingenuity, proving that innovation can flourish along paths utterly foreign to our own experience, and it is a sobering reminder of how fragile knowledge can be, how entire worlds of understanding can be unspooled, one knot at a time, and lost to the flames of conquest. Deep in the dusty soil of what was once ancient Mesopotamia, long before the rise of Babylon or the invention of the wheel, a culture known as the Ubadians was laying the very foundations of civilization. From their settlements dating back to between 5,500 and 4,000 years before the Common Era, archaeologists have unearthed a collection of artifacts that are profoundly unsettling. These are the Ubaid figurines, and they are unlike any other human representations from the ancient world. Crafted from pale, fired clay, they depict humanoid forms with slender, sinuous bodies, elongated heads, and most strikingly, pronounced reptilian features. Their shoulders are often hunched and narrow, their hips wide, and their faces are dominated by large, almond-shaped eyes that slope dramatically toward slitted noses and wide, lipless mouths that seem to suggest a serpent's grin. For generations, the standard interpretation was comfortably familiar. They were filed away as religious idols, representations of gods or demons from a forgotten Mesopotamian pantheon, perhaps depicting a snake deity or a chthonic underworld spirit. This classification was a reflex, a way to contain the bizarre within the known boundaries of ritual and myth, to make the strange feel manageable by giving it a familiar label. But this comfortable explanation has always had holes. If these were gods, why are they so frequently depicted in such mundane, earthly poses? Many of the figurines show these reptilian beings in strikingly human activities. A mother nursing a distinctly non-reptilian baby, a figure holding a mace or a tool, another sitting with its legs crossed in a posture of contemplation or rest. They lack the imposing, hierarchical grandeur we associate with divine statues meant for worship. They feel more like snapshots of daily life, but a daily life populated by beings that are fundamentally other. This dissonance has led to a wave of more speculative but profoundly intriguing reinterpretations that venture far beyond the religious idol box. One compelling theory suggests these figurines are not depicting literal reptilian people, but are instead a form of shamanistic art. In many early cultures, ritual practitioners would enter trance states using psychoactive plants, seeking visions and communication with the spirit world. A common trope in these visionary experiences across the globe is the sensation of transformation, of merging with an animal spirit or perceiving the world through an animal's consciousness. The Ubaid figurines could be a tangible record of such experiences. A shaman, having ingested a potent substance, might feel their skin crawl, their vision sharpen, and their consciousness merge with that of a powerful lizard or snake spirit, a creature deeply symbolic of rebirth, the earth, and primal wisdom. Upon returning from the trance, they or an artist in their community might then sculpt this vision of the human-animal hybrid, not as a god to be worshipped, but as a document of a profound spiritual journey, a portrait of the shaman's transformed self in the spirit realm. An even more radical, though highly speculative, interpretation pushes this idea into the realm of proto-science. What if the reptilian features are not symbolic at all, but observational? The Ubaid culture existed at the dawn of agriculture and animal domestication. Their survival depended on an incredibly intimate and detailed knowledge of the natural world. They would have spent generations observing the life cycles of animals from birth to death. Is it so far-fetched to imagine that in their study of lizards and snakes, they began to recognize a distant biological kinship? They would have seen the skeletal structure of a lizard with its 4 limbs and a spine, and noted the similarities to their own bodies. They might have witnessed the incredible regenerative ability of a lizard to lose and regrow its tail, a concept of healing and renewal that would seem like magic. The figurines, in this light, are not depictions of gods or spirit visions, but early hypotheses about life itself. They could represent a primitive, pre-literate attempt to understand genetics and evolution, a tangible expression of the idea that all life is connected, and perhaps even shares a common ancient ancestor. The nursing mother figure is the key here. It powerfully connects this reptilian form with the most fundamental mammalian act, suggesting a deep biological linkage between the two. It's a sculpture posing a philosophical question: from where did we come? This shift in perspective, from religious idol to potential scientific or shamanic document, is what makes the Ubaid figurines so important. They force us to dismantle our own arrogant timelines of human understanding. We often operate under the assumption that early humans were solely pragmatic or purely mystical, that abstract biological concepts like evolutionary kinship were far beyond their grasp. These strange, silent figures suggest otherwise. They hint at a culture that was not just surviving, but was actively contemplating its place in the web of life, using the tools of art and symbolism to explore the biggest questions of existence. They challenge the very definition of science, suggesting it might begin not in a laboratory with written formulas, but in the quiet observation of a lizard basking on a sun-heated rock and the dawning, profound realization that its life and our own are spun from the same ancient thread. The Ubaid lizard figurines may never give up their secrets fully, but their greatest gift is the permission they give us to imagine our ancestors not as primitive simpletons, but as deep thinkers and keen observers, using the clay beneath their feet to document the first, stirring whispers of a truly connected worldview. Carved into the stone walls of a dark crypt deep within the Hathor temple at Dendera, a series of bizarre reliefs have ignited a modern controversy that pits orthodox Egyptology against a tantalizing, if highly speculative, vision of the ancient past. The images are striking and undeniably odd. They show a large, oblong object that looks remarkably like a giant, translucent light bulb with a serpentine filament winding through its center. This bulb is nestled inside a container or base, held aloft by a pillar, and connected to a box that a towering figure seems to be operating. To the priests and artisans who carved it over 2,000 years ago, its meaning was likely as clear as day. To modern eyes, however, it is a riddle wrapped in a mystery, an image so anachronistically familiar that it begs for an explanation that defies our standard historical timelines. The immediate, visceral reaction for many is to see exactly what it appears to be: an electric light bulb. This interpretation, while dismissed out of hand by mainstream scholars, forces a profound and uncomfortable question. Could the ancient Egyptians have possessed a form of technology so advanced that we have completely missed its traces in the archaeological record? The mainstream Egyptological explanation for the Dendera reliefs is deeply rooted in the complex and rich symbolism of ancient Egyptian mythology. Scholars point to the accompanying hieroglyphs and the broader context of the temple, which is dedicated to Hathor, the goddess of the sky, women, and fertility. In this view, the so-called bulb is not a technological device at all, but a symbolic representation of a deeply spiritual concept. They identify the oblong object as a lotus flower, a powerful symbol of creation and rebirth emerging from the primordial waters. The serpent inside is not a filament but the snake god Harsomptus, a manifestation of the sun god, representing the divine life force and energy emanating into the world. The entire scene, according to this interpretation, is a cosmological diagram depicting the Egyptian creation myth, specifically the moment the world is born from the lotus that rose from the waters of Nun. The box is not a battery or generator, but a jed pillar, a symbol of stability, and the figure is not an electrician but a god, perhaps Ptah, presiding over this sacred act of Genesis. This reading is coherent, fits perfectly within the established framework of Egyptian religious art, and requires no invention of lost technologies. It is the safe, academically sound interpretation, the one taught in universities and presented in museum guides. Yet, the light bulb theory persists with a stubborn vitality, fueled by the powerful human tendency to see the familiar in the foreign. Proponents of this view, often engineers and alternative historians rather than trained Egyptologists, argue that we are making a critical error by forcing every ancient image into a purely religious or symbolic box. They contend that the Egyptians, masters of practical engineering who built the pyramids with near impossible precision, were certainly capable of empirical discovery and technological innovation. Their argument hinges on the relief's startlingly mechanical appearance. The object has a distinct, glass-like enclosure, a defined base that resembles a socket, and a filament shaped like a wavy snake that is held in place by two arms, not unlike modern light bulb supports. They point to the box, which they suggest could be a power source like a primitive battery, a concept not entirely without precedent, given the discovery of objects like the Baghdad Battery. The figure operating it is seen as an engineer or priest scientist, perhaps using the device to illuminate the dark, windowless inner chambers of the temple for rituals or construction. This interpretation, while far outside the mainstream, is compelling because it speaks to a modern aesthetic. It looks like a blueprint, and we are a culture that trusts blueprints. The real significance of the Dendera relief, however, lies not in proving whether the Egyptians had electricity, but in what the debate itself reveals about our relationship with the past. This single carved image acts as a perfect Rorschach test for historical interpretation. When we look at it, do we see only what we already know, gods, myths, and symbols? Or do we allow for the possibility of radical discontinuity, for the idea that a civilization's technological knowledge could arise, be applied in a specific context, and then vanish without a trace, leaving behind only a cryptic diagram that later generations can only understand as magic or religion? The Dendera light forces us to confront the limits of our own understanding and the inherent arrogance in assuming we can fully comprehend an ancient mindset. We project our own world onto the past. An engineer sees a circuit diagram, a priest sees a creation myth. The truth is likely forever lost in the cultural chasm that separates us from the people of Dendera. This artifact, more than almost any other, exemplifies the delicate tightrope walk of studying ancient history. It warns us against the easy dismissal of all unconventional ideas as foolishness, but it also cautions us against the seductive lure of sensationalism that ignores overwhelming cultural context. It teaches us that the boundary between myth and technology might be far more porous than we think. For many ancient cultures, the two were not separate categories but intertwined realities. A ritual was a technology for interacting with the divine, and a clever device might be seen as a gift from the gods. The Dendera relief may forever remain an enigmatic blend of both, a powerful symbol that just happens to look exactly like a piece of our own world, reminding us that the past holds onto its secrets tightly, often showing us just enough to make us wonder, but never quite enough to let us be certain. Painted on gazelle skin in the year 1513, in the bustling port city of Constantinople, a map was completed that would become a cornerstone of modern mystery. Its creator was an admiral and cartographer of the Ottoman Empire named Piri Reis, and he freely admitted his work was not born from his own original voyages, but was a compilation, a mosaic pieced together from far older sources. In his own marginal notes, he references using 20 different charts and maps, some dating back to the time of Alexander the Great, and even one that he claimed was drawn by a Genoese sailor named Columbus. For centuries, this stunningly detailed world chart was admired as a beautiful example of early 16th century Ottoman cartography, a curious blend of the known and the speculative, with sea monsters gracing the Atlantic and accurate coastlines of Europe and Africa. It was a masterpiece of its time, but it was still very much a product of its time, or so everyone believed. The true bombshell was dropped in 1929, when the map was rediscovered in the Topkapi Palace Library and subjected to modern geographical analysis. Scholars were stunned to discover that it didn't just show the old world. It appeared to show a landmass far to the south, beyond the tip of Africa, with a coastline that was chillingly, impossibly accurate. This wasn't just any land. It seemed to be the northern coast of Antarctica, a continent that would not be officially discovered for another 300 years. And the most baffling detail of all, this Antarctica was depicted not under miles of glacial ice, but as a green and flowing land, its rivers and mountains rendered with a precision that suggested the cartographer had access to a survey done when the continent was last ice-free, a period that ended millions of years before the emergence of modern humans. This revelation was like a historical earthquake, sending tremors through the entire field of cartographic history. The immediate and most sensational interpretation was that the Piri Reis map was definitive proof of a hyper-advanced ancient civilization, a global seafaring culture like Atlantis that had mapped the entire world with a technological sophistication we can barely imagine, and that their knowledge had been passed down through the ages in fragments, only to be captured by this Ottoman admiral. It was a theory that captured the public imagination and became a flagship piece of evidence for every alternative history book for decades. It seemed to suggest that our entire understanding of human progress was a lie, that a golden age of exploration had risen and fallen in prehistory, leaving behind only this single, tantalizing ghost in the lines of ink on a dried animal skin. The map was transformed from a medieval curiosity into a potential relic of a lost epoch, a window into a past so advanced it defied belief. Modern scholarship, however, has taken a more measured, though no less fascinating, approach to unraveling this enigma. The key to understanding the map lies in taking Piri Reis at his word, that he was a compiler. The real mystery isn't the map itself, but the nature of the source materials he had on his desk in 1513. The most widely accepted theory among mainstream historians is that the controversial southern landmass is not Antarctica at all, but a composite and distorted representation of the recently discovered coast of South America, blended with mythical terra australis incognita, the long-theorized, unknown southern land that geographers since Ptolemy believed must exist to balance out the landmass of the Northern Hemisphere. The accurate details of the Brazilian coast could easily have been obtained from Portuguese sailors who were actively exploring the region. The parts that seem to match Antarctica, proponents argue, are simply a coincidence of cartographic guesswork, a lucky strike of artistic license that accidentally aligned with a reality no one at the time could have known. But even this more conservative explanation has a thrilling implication. It suggests that the age of exploration was far more advanced and interconnected than our history books typically portray. The idea that an Ottoman admiral in Constantinople could have access to the latest Portuguese and Spanish charts speaks to a vibrant, shadowy world of espionage, trade, and intellectual exchange happening behind the scenes of official royal courts. Knowledge of the New World was the most valuable currency on Earth, and it was flowing through unexpected channels. Piri Reis himself might have gotten his information from a captured Spanish sailor, a Venetian spy, or a Jewish mapmaker who had fled the Inquisition, bringing secret knowledge with him to Istanbul. This transforms the map from a potential artifact of Atlantis into a snapshot of a different kind of lost history, the history of a nascent global intelligence network operating at the very dawn of the modern era. There is, however, a third, more speculative but compelling possibility that bridges the gap between these two extremes. What if the source maps Piri Rise used weren't from ancient super-civilizations, but from a much more recent, yet still unrecorded, era of exploration? We know that Polynesian voyagers had been traversing the vast Pacific for millennia, reaching remote islands with navigational skills we are only beginning to appreciate. Is it so impossible that some unknown group of medieval or even classical mariners, Phoenicians, Malays, or perhaps a lost Viking expedition, sailed far further south than anyone has ever credited? They might have encountered the northernmost tips of the Antarctic Peninsula during a medieval warm period, when sea ice was reduced, and charted a rugged, glaciated coastline that they mistook for a more temperate land. These charts, passed from hand to hand, ship to ship, and century to century, could have degraded into the sources that eventually found their way to Piri Rise. This wouldn't require a lost civilization with advanced technology, but it would require us to dramatically expand our understanding of the range and ambition of pre-Columbian explorers, adding a whole new chapter of forgotten voyages to the story of human discovery. Ultimately, the enduring power of the Piri Rise map lies in its stubborn refusal to be easily categorized. It is a palimpsest of human knowledge, a layer cake of information from different eras and sources, all compressed into a single image. It challenges our neat timelines not by providing a clear answer, but by presenting an irresolvable ambiguity. It forces us to acknowledge the vast gaps in our historical record, the countless voyages that left no written account, the maps that were drawn on perishable materials and turned to dust, the sailors whose discoveries died with them. The map is a testament to the fact that history is not just what was written down by the winners, but also what was sketched on a chart by an anonymous hand, copied by a scholar, and preserved by chance. It reminds us that the world was being discovered in fits and starts for thousands of years, and that the official age of discovery was merely the moment when Europe finally caught up, consolidated this scattered, ancient knowledge, and decided to write itself into the narrative as the protagonist. The Piri Rise map is not a smoking gun for ancient astronauts, but it is a profound and haunting silhouette of all the forgotten explorers, the lost journeys, and the silent chapters of courage and curiosity that still wait just beyond the edge of the known for us to finally give them a voice. Deep in the humid jungles of Costa Rica's Diquis Delta, amidst the calls of howler monkeys and the tangled green vines, lies one of archaeology's most visually striking and intellectually stubborn puzzles. Scattered across the landscape, as if abandoned by a race of giants, are hundreds of near-perfectly spherical stone balls, ranging in size from a mere few centimeters to over 2.5 meters in diameter and weighing up to 16 tons. These spheres are crafted from grandarite, a hard, igneous rock that is brutally resistant to shaping. For decades after their modern discovery in the 1930s by crews from the United Fruit Company clearing land for banana plantations, the prevailing theories about their purpose were comfortably abstract. They were seen as celestial markers, their alignments mapping out constellations or solstice events for ancient stargazers. Others argued they were symbols of power and status, the larger ones serving as intimidating proclamations of a chief's authority, much like the monumental heads of Easter Island. They were mysterious, beautiful, and utterly enigmatic, the ultimate ceremonial objects, their true meaning lost to the jungle and to time, their perfection a testament to a spiritual rather than a practical drive. This mystical interpretation, however, has always contained a frustrating flaw, a complete lack of celestial or ceremonial context. Unlike other ancient monuments with clear astronomical alignments, such as Stonehenge or the Pyramid of the Sun at Teotihuacan, no consistent, verifiable pattern has ever been conclusively demonstrated between the spheres. They are found in clusters, in lines, and in solitary positions, with no overarching design that points to a unified cosmic plan. Furthermore, they are not typically found in what we would classify as overtly sacred spaces, at the hearts of temples or atop pyramids. Instead, they are often located in what appear to be residential areas or, most intriguingly, near the foundations of large, since vanished wooden structures. This dissonance between the object's incredible precision and its seemingly mundane placement has fueled a quiet revolution in thinking, pushing researchers to look beyond the spiritual and consider a far more grounded, yet no less brilliant purpose. The breakthrough in understanding these spheres came from a simple but profound shift in perspective, treating them not as ritual art but as components of a machine. The key was to stop asking what they meant and start asking what they did. A team of archaeologists and engineers, led by researchers from the University of Costa Rica, began to analyze the spheres not for their symbolic value, but for their physical properties. They noted that many of the spheres, particularly those found in groups, showed very specific wear patterns, flat spots, abrasions, and polished surfaces that were inconsistent with them being permanently set in place as monuments. These marks told a story of movement, of contact, of friction. This observation sparked a radical new theory. What if the spheres were not stationary markers at all, but were designed to move? What if they were the world's most durable and massive set of ball bearings? Imagine the construction challenges faced by the ancient builders of the Diquis Delta. They were erecting enormous, impressive buildings, long communal houses, elevated platforms, and ceremonial structures using massive wooden posts and beams. The one thing their environment did not provide was an easy way to move these colossal timbers from the forest to the building site through muddy, uneven terrain. The new theory proposes a brilliantly simple solution. They would have constructed wooden cradles or frames to hold these perfectly round stone spheres. A heavy log could then be rolled onto this platform, and with a team of people pulling with ropes, the entire immense weight could be transferred onto the spheres, which would roll with minimal friction, allowing the log to be transported and positioned with a level of control and precision that would be impossible with mere dragging or levering. The spheres effectively invented the wheel for a specific, heavy lifting purpose without ever needing to invent the axle. This isn't just a theory. Experiments using replicas have demonstrated that a small team can move astonishingly heavy weights using this exact method. The spheres cease to be symbols and become tools, the central component in a sophisticated transportation technology. This practical application dovetails perfectly with another compelling idea: their use in architectural leveling. The ancient sites where these spheres are found, such as Batambul and El Silencio, are often on slightly uneven ground. To construct a large, stable building, the foundation must be perfectly level. A large stone sphere, precisely calibrated, would make an ideal leveling device. Builders could place it on a proposed foundation point and see exactly how it settled. Its perfect roundness would instantly reveal any incline, allowing them to pack earth or stone underneath to achieve a perfectly flat base. The very perfection that made them seem mysterious and ceremonial is exactly what would make them invaluable for this intensely practical engineering task. In this light, the spheres are not monuments to power, but instruments of precision, the ancient equivalent of a surveyor's transit or a carpenter's level, essential for ensuring the stability and longevity of their most important constructions. The true marvel, then, shifts from the question of purpose to the mind-boggling question of method. How did a pre-Columbian culture without metal tools, without the wheel, and without draft animals create objects of such geometric perfection from one of the hardest stones on Earth? The answer is a testament to a lost school of stone-working expertise that combined patience, empirical physics, and generations of accumulated knowledge. Researchers believe the process began by identifying a large boulder of the right material. They would then use smaller, harder stones as hammers to fracture and peck away at the surface, gradually roughing out a spherical shape. The real genius came in the finishing. They likely used a combination of heat and controlled, rapid cooling, perhaps with water, to create micro-fractures on the surface, making it easier to abrade. Then, for the final stage, they would have used sand as a grinding agent, possibly rotating the sphere within a concave stone or wooden cradle packed with abrasive sand and water. Through weeks or months of relentless grinding, this process would slowly wear down the high points, the constant rotation and even pressure naturally guiding the stone toward a perfect sphere through the unyielding laws of physics. This wasn't magic, it was a masterful application of material science, a physical algorithm of abrasion and rotation that yielded a mathematically ideal form. The reclassification of the Costa Rican stone spheres is therefore a monumental shift in our perception of pre-Columbian societies in the region. It moves them from the realm of the mystical into the realm of the ingeniously practical. We are no longer looking at a culture solely focused on gods and stars, but at a society of sophisticated engineers, project managers, and skilled artisans. They possessed a profound understanding of geometry, not as an abstract concept, but as a tangible tool for solving real-world problems of logistics and construction. They saw a problem, how to move massive objects and build on unstable ground, and they engineered a brilliantly elegant solution hidden in plain sight, the perfect sphere. Their legacy is not a whispered secret from the spirit world, but a solid granite testament to the fact that human ingenuity, when faced with a formidable challenge, will always find a